السلام عليكم.
وعليكم السلام. حسنا، اهلا وسهلا. اهلا وسهلا.
أهلا، صافا بخير؟
صافا الحمد لله. انتم بخير؟ كلشي مزيان؟
صافا الحمد لله. جو بونس بديتي اللايف ياك؟
لحت اللايف وقديت لكم.
صافي. بونس خصنا لا مان باش نبارطاجي.
انا نعطيك الامان تو سويت. نومي انيماتور. نومي انيماتور شكون؟ حسنا. Great. صافي دونك اللايف راه بدا. مي دونك جو يلا الله يعاونكم احسنا.
ميرسي بوكو.
Salam, girls.
Salam, Islam. Ça va?
Ça va.
How are you?
How's it going?
Fine, thank you. How are you?
I am very well. Thank you for having me over.
Oh, thank you for accepting the invitation.
Cool. So we're going to start in 10 minutes. We still have time. Would it be okay if you make me co-host so I can just try,
Okay.
I can just test the screen sharing.
But I need it back.
All right, but I think you can I share my screen? I should be able to share my screen, right?
And I have to make you host so that you can share your screen.
You cannot make me co-host.
No.
Oh, you don't have that option. Okay, in my Zoom, I do have it actually for teaching and all. Right, so because I need to share my screen at some point, right? So you're gonna make me co-host or can I share directly? Because I can't right now.
I will make you host so that you can share the screen, and after you finish your presentation, please make me host again.
Okay, so I need, this is Hasna, right?
Yeah, Hasna, oui.
Okay, great. So I need to make your host again. Okay,
Yes.
cool. Sounds good, I guess. That's fine. Cool.
Hi, hello everyone.
Hi, Bushra, right?
Hi, Professor Islam.
Very nice event. Very nice event yesterday. Well done.
Oh, thank you so much. I'm so happy.
I am too, actually, and I'm so proud of you. Let me just put my camera up. It's such, you know, like truly, you know, like leading such an initiative. It's so good, and being in line with all those universities, and it's so nice to see the youth, you know, young researchers, particularly females, leading and doing this. So very nice.
Thank you. Thank you. It's encouraging because we still in our first experience, second and because Hasna is second year in PhD and I am a PhD candidate, donc it's encouraging us.
Definitely, definitely. That's so cool. And keep doing this, keep taking leadership, because that's how you do it. It's just, you know, by jumping and saying, I want to do it, I want to help.
It's not easy and take a lot of time, but we try to do it. Yes.
Okay, cool. Very nice. And you guys are also doing on YouTube, which is really nice. I've never done it. Is it like maybe we can, I don't think it's so difficult to do that both, you know, live streaming on YouTube.
No, it's not difficult, but we just link it with the YouTube channel of our university. So it's just a technical it's not it's not easy. It's not difficult.
All right, so I'll just then turn my camera off. Oh, I can see myself there on the slides because now I'm talking, I guess, and I can see here. So that's one of the I started preparing my slides. So like, and then I noticed that there is a bar, like I have a bar on top, and the video goes on top in the right, you know, the top right corner. And I was like, okay, have the, you know, like there's like information hidden, included there. So I started changing a little bit the format because with Zoom you have that, but when you're preparing, you're not aware of that.
Yeah.
Yes.
Okay, cool. So I'll leave you up to your preparation. I'll just gonna turn my camera off and let me know when we get started.
Okay, thank you so much.
Hello, Professor Selma.
Salam.
Salam.
So I have a question. Sorry, for the panel discussion, approximately when I'm going to be tuned in until 7 p.m. my time. Okay, so until the end. So when does it start? Is it the last half an hour or is it the last hour?
Yes, the last half an hour.
The last half an hour, excellent. Because that's the juicy part where, you know, we can get to ask questions and also
yes, exactly.
Okay, cool.
Hi, Professor Selma. I hope you're doing well. Thank you for joining.
Thank you. How are you?
Good. Thank you. Thank you for you.
Bouchra?
Oui, Madame Selma.
On a 5 speakers aujourd'hui.
5 speakers, oui. La même chose qu'hier.
Parce que je pense que j'ai pas la dernière version de le programme.
D'accord. J'ai envoyé le matin, je pense.
Ah, le matin? D'accord. Oui.
Oui.
Voilà, j'ai vu que tu as envoyé le matin. Oui, merci.
D'accord. Asna?
Oui.
Est-ce qu'on est en live ou pas encore?
Oui, on est en live.
Ah, ok.
We'll wait just 2 minutes. At 2 p.m. we'll start. Hello everyone. So I think it's time to start the second session of WiDS. So first of all, I hope that everyone is okay. I'm gonna present myself. I am Hasna Zarwawi. I'm a software engineer and a PhD student at the MSDA lab at UM6P, University Mohammed VI Polytechnic. So I work under the supervision of Professor Ali Idri, and I work in the field of developing deep learning techniques to the diagnosis of breast cancer. So I want to welcome all the participants of the YouTube Live. You feel free to share and with your friends and your colleagues. Also, I want to thank all the great speakers that we have and for being with us and accepting the invitation. Also, I want to thank Professor Selma and Professor Ikram, and without forgetting the organization committee. So also I want to thank UM6P and MSDA Lab for allowing us and helping us to organize this event. I just want to tell you that yesterday we started the with Women in Data Science event, so you can rewatch the live of yesterday in YouTube channel of UM6P, and also this session will be it will be saved in the YouTube channel. So just to remember you, Women in Data Science, it is an event that allows and encourage women that work in the data science field. So we gather all the women that are that work or do their research in this field in order to promote and to encourage women, young women to pursue this career in data science. So also I want, given the host to Professor Selma, I want to thank the organization committee, Bushra Shammam, myself, Safa Al-Misawi, Sana Al-Misawi, and Fatima Zahra Al-Hamra. So I will make you host, Professor Selma, so that you can do the openings.
Thank you, Hasna. Before starting, I want to apologize for the noise with me. There are some works at the uni here. I would like to congratulate the organizers of this event for their organization and for picking up exceptional speakers for this event. So congratulations and thank you for making me part of this event. I really enjoyed myself yesterday and learned lots of things. We heard about data science in academia, about new methods in explainable AA. We had some insights about the scalable data analysis. We also had some insights about how we use data science in practice, both in academia and in industry. So that was a very interesting topics. We also had shared experience from all our speakers of yesterday, and thank you for that. I think it's valuable for young researchers to know the experience of older, let's say, experienced women in the field. Today again, there is a great program waiting for us. We will start our afternoon with Professor Islam Raqiq from Basira Lab in Turkey, who is going to speak to us about RISE with minimal resources, insights and challenges. Then our colleague from OCP, Hajar Falih, is going to talk to us about industry and data science. Then we will welcome Professor Hasna Hashimi from Université Moulay Souleiman, who is going to talk about bio-inspired algorithm, female algorithm FA. Then we'll have Professor Dina Abdel Hafiz from Egypt, who is going to talk about deep learning applied to breast cancer. I think this topic is important for you, Hasna, in particular. Last but not least, Professor Dima Damin from University of Bristol in the UK is going to share with us her experience and vision about egocentric. So we're looking forward to all the talks. Let's start. Thank you, Hasna.
Thank you, Professor Selma, and I think I made you Islam the host.
Yeah, thank you so much. Okay, so let me just start by sharing my screen. I would like to thank you all first for inviting me and for organizing and leading such a wonderful event. So today my talk is not too technical. It's more about my journey. So I hope you find some inspiration in it. So do you guys see my screen? Okay, wonderful.
Yes.
Great. So let me start from the beginning. So I'm going to give you just an overlook of my academic background. I completed my bachelor degree in Tunisia and did my undergrad at Essiers in France, followed by a master's in science at École Normale Supérieure. That was in computer vision and machine learning. After that, I moved to the UK in Edinburgh, where I completed my PhD in 3 years. And during my PhD, I got the amazing opportunities to visit Stanford and Johns Hopkins. Following that, I completed my postdoc for 2 years at the University of North Carolina, and I started looking for jobs as assistant professor, so I got one at the University of Dundee in Scotland. So in the last 2 years, I moved to Istanbul Technical University, where I am right now. So this is just a big overview of my academic travels and experiences. Now let's get to the real talk here. So as scientists, data scientists and researchers, we know that we all start from sites. And sites, this is what we can observe, what we can see, what we can describe. And this is the data. It's our little or big treasure, okay? Depending on you have a small data or a big data. But from data, what is more important, while collecting data is important, having data is important, what is more important than that, or paramount for improving our understanding of science, is deriving meaning from the data. And that's what we call insights. So it's an inner sight that you are trying, you're giving your inner sight into the data. You're trying to interpret, you're trying to explain it. And this is what we actually call metadata. So metadata is the data that explains the data, okay? So this is how I got inspired to name my research lab Basira. So Basira, that means in Arabic insight. And I started it in 2017. That was in July. I still remember the day I launched the website. Maybe you guys have looked at that. So the journey since then, in the last 3 years, was very interesting, filled definitely with lots of challenges, lots of celebrations, as you guys see, like, coffee time, conference time, travel time. And in those 3 years, there are lots of events that happen. So I'm gonna let you in on a few secrets of my journey today through this short talk. So since we are today taking part in the Women in Data Science event, so I think it is reasonable to start from the data, okay? So let me give a very brief summary or overview of the Basira Lab achievements in numbers. Here we go. So since 2017 up to 2020, I've supervised more than 40 students. We had more than 65 publications in high impact journals and class A1, B1 conferences, co-organized 6 international workshops, particularly in conjunction with MICAI conference. Currently, we have 5 mentors at the Basira Lab. These are mentors who mentor primarily undergrad students from Turkey, Germany, and Tunisia. We have collaborators from different international institutions, including different countries, Tunisia, USA, UK, China. In terms of awards, we had students at the Basira Lab had 8 awards, 14 orals across MICAI conference, workshops, and other conferences. And we've been involved in organizing committees, more than 9, including, Women in MICAI, Progress, Prime Workshop, Connectomics in Neuroimaging, Machine Learning and Medical Imaging, among others. So in terms of funding, in the last 2 years, we secured €500,000 coming from the international, from the TÜBİTAK funding, which is a Turkish funding, and also from European Horizon 2020, the Marie Curie Fellowship. And all of these stats are reflected on our global outreach. So we have more than 20K global visits for the last 3 years since the inception of the lab. So now coming to the research outcomes, what do we produce? What did we produce over the last 3 years? So we had 21 presentations. These are uploaded on YouTube. So feel free to look at the Basira Lab YouTube channel. Most of the papers, many of the papers, not most, many of the papers are recorded. You can watch the technical work in detail covering machine learning, deep learning, applied to neuroscience, neurological disorders, imaging, etc. 2020, we uploaded 28 GitHub codes. These are, this is to support open science. So you can basically download the code, you can try it, you can build on it. And it's, these are all cutting edge research projects that we are currently working on at the lab. So different, interviews we had last year featured in, for example, RCIP. This is a computer vision international magazine that's online. Also at ITU, my university, and there's a lot to celebrate. Now, this is the data, more data. Since the inception of Basira Lab, we had 45 members, researchers, and as you guys can notice, 51% are at the undergraduate level. Now, in terms of gender balance, we have a perfect balance between male and female members. And in terms of publications, last year we have 25 publications, primarily spanning the field of predictive intelligence in medicine and integrational network neuroscience. So that these are two fields that we are working on and leading internationally, in addition to diagnosis and other fields. So now, this is a bit boring. You see like numbers, but every single number actually has a story to tell and several rising stars to reveal, not only one. So these plots, they have lots of meanings to reflect on and lots of stories to tell. And today I'm gonna just give you a glimpse because the talk is timed to 30 minutes, so I'll try to stick to that. So going to the second part, which is most important right now. So starting from the data, now let's try to explain that data and understand the why and the how. So the metadata behind the data, rising, from the shoots to from the roots to the shoots. So starting with this, I'm gonna just give you a little bit. I'm just gonna take a little journey about my origin or my roots. So basically, I'm from Tunisia. I grew up in Tunisia. I was born in a city called Sousse in the East Coast. And I love so much, you guys can see the noise, actually I took this video, watching sunrises. But it's not just about, watching the sunrise, it's not about just the sun that is rising. There's a lot of stories, a lot of inspiration in watching this, and I guess all of you guys can relate to that. So I also loved listening to stories about rising suns. And one of them, and I know you guys are organizing this event in Morocco, so probably most of you know this young Muslim who was born in the 9th century, and her name was Fatima Ferry. So Fatima Ferry was born in the city of Qayrawan in Tunisia, and then she moved with her family to Fez, and there she got married. After a few years, her husband and her dad passed away. So they left her with a lot of money. Now imagine if you have a wealth, a lot of money, what would you do with that? So at that time, Fatima basically decided to build a mosque. And with a mosque, she also attached a big, huge library filled with books. And that mosque, the Mosque of Al-Qarawin, it turned into a hub for learners, for seekers of knowledge from all over the world, including Christians, Jews, all walks of life. And that was, like a great starting point for the concept of a university in general. So if, this mosque basically is now in the book of Guinness World Records, and it is defined as the first and oldest university to ever exist, which was quite stunning. So me growing up, listening to the story of this inspiring and leading woman, I was thinking, okay, if she can do it in the 9th century, definitely I can maybe do it also in this century, because maybe I believe that conditions are a lot easier. So that got me started. And then in addition to that, in my upbringing, growing up as a Muslim, my love for science was nurtured by the Quran, which is our holy book. So in the Quran, there are lots of chapters, titles spanning, you know, the cosmos, from the sun to the moon to the star. And you have also, you know, like things related to earth, like bees, ants, spiders, etc. So the Quran basically inspired me, inculcated in me the love of seeking knowledge, starting from the first word of revelation, which is read, and ending with the aspiration, constant aspiration to increase yourself in beneficial knowledge. So I thought, okay, starting from a book, a holy book, I wanted to devour all books that ever existed. But I know it's an put together. These are minds that are sitting about, you know, the memoirs, the journey of different people, a lot of self-help, self-development, about women in science, about, for example, here you can see even Ibn Battuta, there was a book there that I read about it, social physics, new sciences, etc. And that was where, even like, you know, writing well, by the way, this is also a nice book to read on how to write in science. So there was lots of books, and I was like, you know, I wanted to learn more. And I believe that reading is very crucial to anyone, particularly scientists and researchers who want to develop themselves. So if you are not a bookworm, just rethink about it. You are missing out on a lot of things, a lot of magic there. So aside from books, you can learn from books, but also you need to find experts in real life, like masters, you know, like researchers, senior researchers, teachers, someone who would teach you, teach you how to think, how to reason, how to create new ideas. And I was very fortunate to meet my postdoctoral supervisor, Professor Jingang Shen, at the University of North Carolina. So during my postdoc was actually a transformative experience. During those two years, I was exposed to 90% of the knowledge that I have right now, like in terms of machine learning, in terms of deep learning, you know, data analysis, cutting edge research, how to create new ideas. So I still remember when I joined the lab, we have what we call this, you know, journal club happening every Thursday. So every Thursday, you know, the room would be filled with like about 40 students, you know, undergrad, PhDs, postdocs, attending the talk of, you know, one of us presenting their work. And I remember when I was there, it wasn't easy for me to understand, you know, all these concepts. So what I did, I started taking notes. So every time we have a talk, I would be writing, taking a lot of notes. And then on a Monday, what I will do, I will try to retrieve. So this is what we call retrieval, knowledge retrieval. So every Monday, I will sit down at my desk, open my LaTeX file, and start remembering or recalling what the talk was about. And I did this for every single talk. And as you guys can see, the numbers right there are the number of talks. So we had more than about 200 talks. So by the end of the second year, or even the mid of the second year in my postdoc, my brain was bursting with ideas. I had lots of ideas. I started connecting dots. I started integrating concepts, seeing concepts, the same principle in machine learning from different perspectives, like sparsity, for example. So that basically, you know, developed my skills as an engineer, as a thinker, as a researcher. And one of the books that also helped me in that to, you know, discover this strategy is this book. Is called Make It Stick. And I really recommend you guys for reading if you haven't read it yet. So continuing, at the end of my postdoc, I had lots of ideas. So my brain was literally burning. I wanted to create projects, and more. And aside from that, in addition to that, I mean, I also had a passion for neuroscience, for learning about the brain, for, you know, designing new models, new architectures, new losses, you know, all of these things. And I thought, okay, now I can start. I have, you know, good skills. I have this passion, so I can start my own lab. I can start my own thing. I can build my team. But do you guys think that this is enough in research? So the question popped up in my mind. So that was a perfect timing because this was when I moved to the University of Dundee as an assistant professor, and there I started my research lab in 2017. So moving forward now, the problem is like, you know, what you need to do research, or primarily to build a research lab, you need funding, you need money, okay, and you need also data. We know that, so you need research data to work on. So let's start with the funding first. So the only way, the traditional way, is to write grants. So by the way, I did not discover this until my postdoc. So even during my PhD, I didn't know that I needed to spend my life begging for money. Please give me money to do research. So I didn't know about the concept of, you know, grant writing. And this is why I'm teaching even students now. I'm at the undergrad level, like I'm informing them about the process, the unfolding of the academic journey or trajectory as a career. So the basic way is you need to write grants. So when I joined the University of Dundee in the UK, I applied to all possible grants within a year. So I applied for AR UK, CR UK, EPSRC, MRC, and all of those were completely different research projects that I put forward, which means, you know, I wrote 4 different proposals, okay? So after you put your proposal, you need to wait for a few months for people to get back to you and listen, give you some feedback. I mean, experts, not people, the jury members, definitely. So these are generally senior researchers who know the field, etc. So the first grant, oh, sorry. You guys can hear me, right? So the first grant got rejected. Good, okay. The second one, I just froze a bit. And okay, the 2 last ones also rejected. So I spent a whole year trying to get funding, no funding at all. And all my trials or my applications got rejected. So I was thinking, okay, I need a plan B. What is my plan B? Now I need to do something else. So this was when I started, like a few years ago, I started this document, where I'm just kind of writing my reflections or essays in 2014. And the content that I'm going to display right now, it is actually unedited, okay? So which means you can find some typos there, just to let you know. So what I started, what I thought that time, I thought, okay, I'm just gonna quit my job. I need to change my job. This is too hard for me. This is too exhausting, okay? So I'm gonna become a Zen elementary school teacher and have a happy life. So back then, I thought that teaching was so easy, but now that I am teaching, I know it's not easy at all, by the way. So people change, right? Like even the way they're thinking. So I was thinking, okay, I'm gonna get my research job. This is too tiring. You know, it's all constrained by deadlines and competition and, you know, high requirements. So I need to free myself from this career. And the good thing about me started writing generally, the writing, not just for me, I guess for many of you guys who love to write, throughout the process of writing, you figure yourself out and you hit a point where you need to come back and start fixing things. And this is what happened to me. So I said, okay, later on the essay, if the human nature was coded in a way to easily and frequently get trapped into negativity and depression, the human civilization would not have progressed with such tremendous strides. So there should be, there should be a way of solving this, because people are able to do it. They are able to build companies, build labs, whatever you want to do. So I came back to my dream and I said, I want to have my own research lab. I want to teach students not only scientific stuff, but how to conduct research and optimize their path to learning. Learn how to learn, implement, solidify, and learn. So now that I know what I want, now that I really, I become stubborn, I will not let go. I'm not giving up. Then things started to happen. So basically, I went to another plan C. So, and I asked myself the question, do I really need money to do research, train students, and publish work? Like publish, do I really need money? So starting with that, basically, let's look at the answers. I figured not necessarily, but what you need to have is, first, you need to know your destination. You need to know where you want to go. You need to know what do you want to achieve. You need to have a vision, okay? So once you have a vision, it doesn't matter how you get there. You're going to get there anyways. The most important thing is you have a purpose, a sense of purpose and directionality. That is very important. Now the path might change that connects A to B here, but at the end you will figure it out. So this is the first thing. Then I started thinking about why. So you guys need to think, what is your why? Why you want to do this. And there is a nice book, it's called Start With Why. You guys can Google it. It's a great read. So it's important to know why you are doing this, why you want to build a lab, why you want to build a company, why you're doing a PhD, why you're pursuing a master program, right? So all these questions you need to take time to reflect on and answer yourselves. And another thing that I learned, I never took permission to lead. I just led. If I wanted to do something, I just did it. If I wanted to start something, I just did it. So I don't overthink about, do I have the capacity to do it? Can I do it? Do I need the permission of someone to let me do it? No. If you can do it, just do it. So basically, after that, I said, okay, I have all these ideas, and I want to just, have lots of projects I want to implement. It's important to develop your ideas, develop your project, have a vision of the trajectory of your project. So envisioning the unfolding of a research project, beginning to end, is important. You might not, the middle might change, but eventually what you want to create as research to advance science, you need to have some clarity in your thinking. And this is so important. So here, generally, when I start a project with one of my students, this is like a video that I have with one of my students. I'm just charting out the key principles, the whole trajectory of the whole project in the beginning. So after doing that, basically, you will have a clear vision of the project itself. And here we go. So that's the project. And after that, the most important thing after you have a project, you need to have two things: D squared, the deadline and the deliverable. What are you going to have as deadlines and deliverables? And this is, for example, here, this is, preparing for the last MICAI, the MICAI 2020. We got actually 12 publications there, including workshops, and it's all about planning your submissions. And also one important thing, and I think it's one of the vital things, particularly for researchers, is to find good students. And I would say primarily students who are eager to learn. They want to learn. They want to develop their skills in the field. So finding those students, then you can easily work with them. You don't need, how would I say, like you can just, volunteer. You can share your skills, share your knowledge, and you can publish together. And particularly with undergraduate students who are generally these newbies who are very excited about trying their first machine learning or deep learning models, they are very eager to learn and expand their knowledge. So I always say that when you start one step at a time, one brain at a time, one human being at a time, one paper, one story at a time. And this is how we did it. So if one road gets blocked, know that you will have hundreds of roads that will rise up to meet you. So just keep in mind to never give up and keep rolling, basically. So this is, the result, the data demonstrating what I was talking about. So without any funding, in 2018, we got 27 publications by my research lab and all, my amazing students. And now going back to the formula, is it enough to have creative ideas, to design projects, and also passion for your work to create magic? Definitely. And there are always infinite ways of doing it. There is always another way of doing it. So after I did this, after I started publishing, build my lab, no funding for 2 years, then I restarted. I got back again to applying for funding, and I had some more clarity. I knew that every challenge is actually an opportunity, and I knew that now I can do it. But even if it doesn't happen, it's okay. I'm going to put a draft together, write my grant, do my best, let the jury enjoy the reading of my grant. If I get it, I get it. If I don't get it, that's fine. I put a draft together, and it's a vision of my project. So it's a great thing to have. So after that, I started getting funding from European funding, Turkish funding, and this is where things got to roll a bit, more easier, I would say. But still, I would always say it's not vital, as you know, we were taught to have money. So now going quickly to the last part of my talk, so I'm going to brush it over very quickly. So the second part is rise with no funding, now rising with limited data. So the data is so important in research. We are data scientists. We know what data means to us. It's our treasure. So imagine, guys, so like when I tell you about data, all you think about is like, if I want to train a deep learning model, I need a lot of samples. I need a huge data set to train on, to learn from, okay? So at the time I was thinking, okay, a lot of data means computational resources, many GPUs. I don't have GPUs. I don't have NVIDIA stations. So what kind of problems can I work on? Can I still publish high impact work with limited data? And this drove me to thinking about the field, or designing and developing the field of predictive intelligence in medicine. And I call it PRIME. And this is a recurrent workshop at MICAI conference since 2018. So generally for diagnosis in medicine, what we need to collect lots of data about the patient, MRI, maybe CT, maybe functional MRI, particularly neurological disorders, diffusion MRI, right? So that costs money, that takes technologies, need to have scanners, that also takes time of the patient. So the question that I had in mind, wouldn't it be terrific if we can diagnose early and accurately with minimal resources, with limited data, and at lower costs? How can we do that? So the idea is, don't collect more data, but predict more data. So predict more data, generate more data across different dimensions. So in this example, let's say, for example, in neurological disorders, we use T1 weighted MRI, and it's conventionally acquired in many hospitals worldwide. So from T1 weighted MRI, the question is, can I derive brain connectivity? So we started working on what we called morphological brain networks. So it's just a graph that represents the brain connectivity on a morphological level. And then from there, we tried to create data or predict data across domains, functional connectivity, structural connectivity, for example, or different views. Also, we can predict data across different resolutions. So having a low resolution connectome or brain graph or image, we try to span and create high resolution data across time. From a single time point, we foresee the evolution of the whole trajectory. And this is from only one single limited observation. So using this idea, we had lots of works, more than about 50% of the Basira works, they are spanning the PRIME field. And let me give you an idea more about what we do as projects. So for example, along the domain prediction, given a source graph, let's say the source graph captures morphological connectivity, we learn how to predict using geometric deep learning or deep learning models that we design and pioneer functional connectivity. Or from a source graph, we try to generate multiple graphs at the same time. So more data, we are creating more data. Now, when it comes to resolution, from a low resolution graph, we can super resolve it, basically. We can generate a high resolution graph with more nodes, more connectivity. We learn more about the brain map, the brain inner working in health and also in disease. Now, across time, given a single observation, we can also span and predict the whole trajectory right there. So you guys can see, we learned the mapping FT, and we can predict the whole trajectory. So across these three dimensions, domain, time, and resolution, there comes the integration task. And this is one of the things that we introduced. It's called, integration network neuroscience, where we introduced the concept of a connectional brain template. And what is this? You guys can think about it as a roadmap of the human brain, okay? So whether in a particular, in healthy circumstances, like if someone is healthy, in a healthy population, or in a disordered population with autism, schizophrenia, Alzheimer's, etc. So now all of those guys, all of those generated data from a single input sample, okay? All of those generated data, we can use it to enhance the prediction of, for example, of disease classification. We can use it to discover fingerprints, like biomarkers that fingerprint particular disorders, and also for classification, as I mentioned, like distinguishing between disordered and healthy brains. Now, all of those basically show that we can rise also with limited data. With little, you can do a whole lot. You just need to be creative about the way you think about what you have. Whatever you have in hands, that's your treasure. You can always use it to do great things. So going next, now, I also encourage all of you to take initiatives. It's so important, like this one, for example, taking initiatives, joining forces with great minds to advance science, empower minorities, have the will to rise and make the world fair with prime progress. And all of those are actually initiatives that I either initiated or co-chaired with also brilliant minds and colleagues and friends of mine. So now, this journey is definitely challenging, but it's so worth it and it's memorable. And I still remember the day where my students, they gave me my first teaching award, and they just made it, like gave it to me as a gift. This was back in 2018. I still have it on my desk right now. So this was, a very cool, I was like overwhelmed, and it was so heavy to carry. So I put it, there, as you guys can see. And a lot of rewards, you get also birthday gifts like that. So I had a meeting with one of my students, and I was surprised that all my students were there and singing me happy birthday. On the Women International, on the International Women's Day, also, you might get flowers and bouquets. So definitely giving is always, how do I say? You always give from your heart. You do not expect something in return. But when you have it, it just shows you that it was worth it, worth the tiredness, worth the stubbornness, worth every single drop of your, of your energy. So now, if you guys are interested in becoming a mentor or a mentee at the Basira Lab, so please feel free to, to apply. So here in the last year, we had 7 undergrad students who got their papers accepted, and they had co-mentors. So it's great. It's a great experience for both mentors and mentees. We collaborate, we work together, and it's nice to build, international synergies and collaborative works. And for you, if you want to apply, please go to thebasiralab.com. So on the main page, you will see, this apply button. You'll click on it, and then you'll find the form that you can fill out, and it's a Google form. Also, there is a barcode, so you can scan this right now, and you can find it very easily if you are interested into becoming a mentor or a mentee and collaborating. So just to wrap up, the last thing I want to say, start now, empower others, and be sure that the road will always rise up to meet you. And always remember that we never rise alone. We always rise together. So ultimately, I just want to thank, everyone. Thank you for inviting me. Sorry about taking an extra few minutes. Thank you to all my loved ones, my teachers, my students, my collaborators, anyone who inspired me in person and also in books. And at the end, I just want to say, let's get started. Thanks, everyone.
Thank you, Professor Islam. It was really a great talk. You definitely inspire us and give us a lot of motivation to pursue what we are doing. Also, thank you for all the book names that you share. I'm a bookworm, so I will definitely look for these books. Some new titles.
Cool. Yeah, definitely. Reading is amazing. It's just, it opens new dimensions in your thinking.
It's wonderful. So I think I have a question.
Definitely.
Since you talked about the formula for starting new projects, you talked that we have to have a project and the passion, and after that, looking for the funding, etc. So my question is as the following. Since I think researchers always think that the formula to get to be a good researcher is to have projects and a lot of technical skills, and
yes.
also maybe a good computer and GPU, etc.
Yes.
Especially if you work with deep learning. But I think what we are missing is the not technical skills. So can you please tell us what are the key skills that researchers should have to be a good researcher?
That is a great question. Actually, this talk, I would have expanded it into 3 hours, but I just, tried to give a few snapshots of different concepts. for, I would say, talking technical wise, you need to learn from the best. So the best is like if you have first your teachers, but also right now, you can look at, you can find great talks, in conferences in your field. For example, Mikai, CVPR, NeurIPS, ICCV. So you have talks on the internet. You can watch, you can read papers, you can download codes, and, how do I say, try things on your own. So this is going solo, okay? Going solo, it means you need to find the best journals in your field, the best conferences in your field, and start tracking and following up, and have a reading and a writing diet on a daily basis. So every day I tell my students, not all of them are applied, by the way, they're here. So every day you should guys read, have 1 hour reading, 1 hour writing. It makes a huge difference over time. You're gonna feel yourself getting stronger in writing, getting better at reading, getting a lot of ideas. It's okay that the first time you read, you understand 20%. It's fine. But after a year, you're going to understand 90%. That makes a difference, okay? So having a reading diet and I would say, a writing diet. Another thing, I would say, try to find the best teacher. So even if, I would say, collaborators. So even if you are in your own country, try to reach out to people abroad. Maybe you can, they can co-mentor you, co-supervise you. They can just collaborate with your lab. So if you don't have a skill at your lab, try to find someone who has it, okay? And learn from it, because learning from the experts, that's a shortcut. So the hardest way is actually when you're spending time reading. It is good. I mean, it's great. But if you find someone who can explain to you a concept in 10 minutes or 5 minutes, that makes you gain a lot of time. If they're explaining very well and with clarity, that is awesome. There's another thing. There's lots of resources right now on the internet, like on YouTube, there are like courses on deep learning, machine learning, geometric deep learning. Find the best talks. Just, create your own resources of, talks and I know one of my students, Montasar, he does that a lot. He's always like sharing the resources. So basically, try to find the best resources, the best teachers, and learn from them. So that's another thing. And there's a whole lot to talk on. Time management is so important, also, having, how do I say, someone to learn from, joining workshops. If you find a national or international workshop on coding up, Python is important. Coding skills are so important, vital. In terms also of using, GPUs, you're using deep learning. So all of those skills are so important. You can find resources, you can join tutorials online, you can join, workshop online, and you can learn, but don't learn alone. Learning alone is good. Co-learn. And we know in machine learning, ensemble learning is more powerful than a single learner. So try to, learn with other friends, with other colleagues, share, because when you learn something and when you share it afterwards, it sticks in your brain. You'll remember it. But when you learn it just for yourself, you'll eventually forget it. So for example, me, when I showed you the documents, I was taking notes. So when I was taking notes, I knew that I'm going to use that to teach. So I had my intention set when I started my postdoc that I wanted to do my lab. So in the 2 first years, I wanted to maximize my learning. So I had a vision. And this is why I tell you guys, it is important to know why you are doing this. Because when you start reading a book just for fun, it's different from starting reading a book to teach someone. Like your brain, literally, in your brain wiring, the way your brain responds will completely change. And that makes a big difference. So intention is so important, knowing why you're doing that.
Thank you very much.
You're welcome. You're most welcome.
I don't know if there is questions from the attendee or the speakers. I will just check.
I want just to thank you, Professor Islam, for this amazing presentation.
My pleasure.
So much.
Oh, it's my pleasure. Thank you for inviting me, and well done. Just keep rolling.
Thank you. Thank you so much.
So I think we will, if you can make me host again.
Yes, you are host, Hasna.
Okay.
Yes.
So I think now we will have Madame Hajar Fadih. I will give her.
Hello, everyone.
Hello.
Hello.
Do you hear me?
Yes.
Yes.
I just share with you my screen.
Yes, you can share the screen now.
Okay. Do you see it?
Not yet.
Not yet?
No, not yet.
Give me a moment. No?
Yeah, now it's okay.
So, hello everyone. My name is Hajar, and I come actually from a computer science background, and I am currently working as a data scientist at the digital factory of OCP. So, I am glad to be among you today talking about artificial intelligence. And in this talk, I will be using AI to stand for machine learning, data science, artificial intelligence, and advanced analytics, despite the differences in those terms. Okay, so let's go here. So for the story, I got actually interested in AI 9 years ago when I took part of a special program in India. And back then, I was really astonished by its power, especially in sentimental analysis. I moved to France and witnessed AI helping Cancer Institute collaborate together, then worked on a voice assistant for the smart home environment. All this was new to me. And I was thinking of women in rural areas in Morocco losing their babies because they can't get a medical advice, or those children in the Atlas Mountain dying every winter because they couldn't get food on time. I was thinking of those hard-hearing people who rarely goes to school. And AI seemed for me as a superpower, a magician that can solve everything and every problem. I still hold those wishes, but with a different view. Actually, now I think AI is only a tool, and it is up to us human to direct it to the right problem, to the good instead of the bad, and to the inequalities. But if you think AI is neutral, or it cannot be fooled by human biases, or if you believe, as Elon Musk, that AI will rule one day the world, and that now time comes that we should enhance the human capabilities by inserting a sort of a device in our human brain, you ought to consider the following example.
My heart smiles as I bask in their legacies, knowing their lives have altered many destinies. In her eyes, I see my mother's poise. In her face, I glimpse my auntie's grace. In this case of deja vu, a 19th century question comes into view. In a time when Sojourner Truth asked, "Ain't I a woman?" Today, we pose this question to new powers, making bets on artificial intelligence, hope towers. The Amazonians peek through windows blocking deep blues as faces increment scars. Old burns, new urns, collecting data chronicling our past, often forgetting to deal with gender, race, and class. Again, I ask, ain't I a woman? Face by face, the answers seem uncertain. Young and old, proud icons are dismissed. Can machines ever see my queens as I view them? Can machines ever see our grandmothers as we knew them? Ida B. Wells, data science pioneer, hanging facts, stacking stats on the lynching of humanity, teaching truths hidden in data, each entry and omission, a person worthy of respect. Shirley Chisholm, unbought and unbossed, the first Black Congresswoman, but not the first to be misunderstood by machines well-versed in data-driven mistakes. Michelle Obama, unabashed and unafraid to wear her crown of history, yet her crown seems a mystery to systems unsure of her hair. A wig, a bouffant, a toupee, maybe not. Are there no words for our braids and our locks? Does relaxed hair and sunny skin make Oprah the first lady? Even for her face well known, some algorithms fault her, echoing sentiments that strong women are men. We laugh, celebrating the successes of our sisters with serena smiles. No label is worthy of our beauty.
The young lady actually in this video is named Joy. She's a researcher from MIT, and in 2018, she shed on light on the gender biases in AI. In fact, as you've seen in the video, she conducted research on some commercially available face recognition system created by Microsoft, IBM, and the Chinese company Megvii. Those systems were widely used, and she only told this AI, I'm gonna give you pictures of people with different skin tone and with different gender. And all you need to tell me whether this is a male or a female. But the AI replied back saying, yes, I can do that with even greater accuracy, but only if you are a white man. Still, even those commercially available solutions couldn't even identify those well-known women, like the first Congresswoman, the one who fought in the United States for our right to vote. So that was really shocking. But those findings pushes IBM to roll out an improved service. Microsoft said it had already taken steps to improve the accuracy of its facial recognition system. But Megvii, the Chinese company, whose Face Plus software is widely used for identification in the banking, online payment, and ride-sharing service in China, did not even bother to comment. Similarly, in New Zealand, a man of Asian parents had his passport rejected, saying your eyes are closed, even if they are not. But if even those two examples doesn't apply to you, you might consider my next one. So imagine a scenario when you submit your resume online to an HR, you are a woman, you are interested in a data scientist position, and you enter all those qualifications, like your straight A at college, your amazing Kaggle competition, your social activities, all what make you the ideal candidate for the position. And you got simply rejected because this HR believes that men make better data scientists than women. Shocking enough. This is similarly what happened at Amazon. In fact, an Amazon team was building a recruitment AI to rank candidates, but the algorithm learned to systematically downgrade women's CV for technical positions like software engineer or even programmer. Why this happened? It happened simply because the model was trained by observing pattern in resume that the company received in 10 years. So imagine the huge amount of data that this company received and resume that this company received in a 10-year period. And normally, as a data scientist, you think I'm going to get good results. But the truth is that all these 10 years data were male predominant. So the AI penalized resume, including the word woman, as in women engineering club, or I graduated from a women college. So hopefully Amazon is not working with it. I'm gonna move to another example, and here we are talking about diabetic retinopathy. I remember yesterday Nermeen talked about it, showing how Microsoft do it, but here I'm talking mostly about Google. So diabetic retinopathy is a condition caused by bleeding or swelling in the eye due to the fact that maybe your insulin, if you are diabetic and your insulin is not properly handled, that means you get damage in your blood vessels. And the small vessels in the eyes are the first to get affected, causing you this diabetic retinopathy, which basically happens in the back of the eye and which, if not discovered early, can lead you to become blind. In Thailand, it is usually diagnosed by having a clinical worker take a photograph of the retina, sending it to a specialist, and then the specialist reply back. The process takes up to 10 weeks. Hence, Google Health wanted to shorten this time and built an AI capable of identifying signs of diabetic retinopathy from an eye scan with more than 90% accuracy and gives the result in less than 10 minutes. Wow, this seems an outstanding result. They put it in hospital, and medical staff and patients were really frustrated. The AI is rejecting more than the fifth of the images, leading diabetic patients to stand for hours to get a new appointment because the first one was not sufficient. This is due to the quality of the image. The one used in training were with high quality, as we all do in deep learning, but those of real life were bad, lacking light. The second issue is that the 10-minute result was not met due to problem in the internet connection that slowed down the model. So real life is really different from laboratory. The trial was stopped and Google Health paired up with local medical staff to tailor their design to their expectation. So this is to say that it's really different from like when you're coding than in real life. So let's move to a funny example this time. So if I asked you what are the differences between Pandora and the sea bream, la dorade et le pajou, you may say the color, the size, the length, the tail, which seems logical, pretty easy stuff. This is somehow what those AI researchers wanted to do with this fish called tench. So they wanted their model to be able to detect images in which the tench exists and those in which it doesn't exist. They got really good results. They were happy and they asked their model, please tell us what part of the picture helped you to identify this fish. And the model gave the big picture here showing human fingers. Surprising, no. Why did it return this result? Naturally, because the training image featured the fish held up like a trophy. So you may search it on the internet and you'll find people holding tenches and happy with it. And the AI didn't distinguish that the fingers are not part of the fish, that are part of human, and gave that hands and fingers are a very predictive image feature. Really, sometimes I think AI is an obedient servant and not intelligent enough. Anyway, well, that brings us to our final example, COVID. So Imperial College team designed an AI model that, among others, have been used to justify the stay-at-home orders in England and the United States. Nonetheless, the team neither did it share the assumption fed to the model, nor did it update them as we get to know more about COVID. So no one was able to challenge the model or to understand what lies behind the model. And the result was that the AI was highly flawed, and sadly, it's been used upon for policy decision. In a nutshell, these examples that sound as AI failures offers a great room for improvement and shed on light on biases that the system may encounter. However, we do not want to build systems that help us with medical treatment, transportation option, or commercial opportunities only to find out later that this system doesn't work or that they make error. Here rises the question, what does it take from an industry point of view to build a trustworthy and profitable AI other than it is 99.9% accurate? Actually, the first thing to do is to have an AI vision derived from business goals. For the sake of statistics, so economical benefits of AI are estimated really to be high. By 2030, PwC predict that each industry will obtain a gain in GDP of at least 10%. McKinsey assumed it to be 16% higher by 2035, but Accenture were more optimistic, saying it will double by 2035. So the studies vary, but it is important to say that AI and analytics can be very business friendly. But how? The answer is that you should know your business. What are your business goals? Your must-win battles to stay competitive. What do you need to optimize in your processes? What can be your quick win? So this is mainly about identifying where you will axe your AI effort, your artificial intelligence or advanced analytic effort. And from a data scientist perspective, we should have an AI roadmap, identify the business processes, whether we want to work in product development, production, sales, marketing, supply chain, pricing, HR, finance, all those areas, where you want to use your data and AI. And the data scientist shall keep in mind why we are starting a new business case and where we want to get. The business process is to be understood, and the big picture is important to keep in mind. Second, it is about the asset, and the assets are simply data. I mean, we should understand the current state of data. What data exists? Where does it reside? How can it be accessed? What's its quality? Can it be linked to another data? How much effort does retrieval take? In short, data should abide by some principle as suggested by European Commission. It's called the FAIR principle: definable, accessible, interoperable, and reusable. It is important also to link data with the use case. A data scientist must evaluate data, check for biases, and confirm the feasibility with the opportunity. The third thing are the enablers. It is the beautiful mix between human and technology. I like an MIT-like word. If you want to have a digital lighthouse, you should have a place actually where people work beyond silos, outside in, and in an agile manner. In other terms, it means we should form a multidisciplinary team that collaboratively pushes for a common objective that we define in the first point, in the vision. And this team should think outside in, which means that we should not, as a data scientist, stay behind computers and just coding. We should go out to real life, looking for insights from customer, seeing how a chemical plant operator is working, etc. And we should deliver results in an agile manner, which help evaluate the output in weeks rather than months. From a technology perspective, we shall also not only look at the data sources, but the pipeline through which data flows from the source to the algorithm. Because one failure cause for the model that seems really perfectly performing during development is that come deployment time, the data being fed to the algorithm is not reliable anymore, doesn't update regularly, changes unpredictably, or otherwise has some differences from the data that was used first in the model. So we should keep that in mind. Really know the architecture, how data flows, and go out and see how real life is. Last but not least, we should keep in mind that in industry, a model decision should be explainable and justified. We can't rely on black boxes AI. Otherwise, the consequences may be very harmful. The AI, once in production, should be monitored and maintained when needed, especially when we have new sources of data or when we change some assumption. As well, we shall keep in mind that sharing is caring. So if you care about AI, then speak about it. Get people engaged. Create a data culture within your industry. It builds trust and awareness on the subject. And the last point is, don't forget that learning is a perpetual mission. And in this area, it's a must, since algorithms are evolving and science as well. To conclude, remember that the highest level of AA maturity is when the whole company moves in union, when silos are dissolved, and when data and AI are used by everyone as part of their activity. And as a woman, always keep in mind those great women who shaped the way for us to be able to gather and speak about women in data science. Let us honor them and pave the way for less inequalities and more impact. The nice music playing on the back is not an effect. It is the 10th symphony that Beethoven couldn't finish years ago, and that now AI completed it in a very beautiful manner. So believe in yourself and use AI. Thank you.
Thank you, Madam Hajar, for this great presentation and also for accepting the invitation to be with us today. I was really shocked in the beginning of the presentation to know how the discrimination that we still have, even with the AI, and I really hope that in the future we will not have it, hopefully. So I don't know if one of the speakers or the participants have a question. Now we just check.
Maybe
so yes, Professor Selma.
Thank you, Hasna. Thank you, Hajar, for your presentation. I learned a lot of things. My question is, can you tell us just a word about how you use AI in your daily work or around you at OCP?
Yeah, actually, at OCP, we're working at optimizing several things like processes in industry, in chemical plants, whether in Jorflasfar or in Ribka in the mine, or even in Vengrid. So, and we work also with commercials to predict, for example, the cost of sending a product from a location A to a location B. So we're working really on making impact in the business.
Thank
and
you.
I know about the agri-tech, which works and focuses on agriculture. I love their work.
I have a question, Hajar.
Yes, for sure.
Since you are a data scientist in the industry field, what are the challenges that you face as a woman in this field?
Actually, as a woman in the industry, not even in data science, you face it because it's actually mostly male predominant. And if you go to a plant, to a chemical plant, for example, in Jorfa Asfar, you see few women, especially when you're doing something related with technology. But I really have hope for that, because when you get out of your mind that you are a woman and you see, you tell yourself, I am competent, I can do that, then that open your head and your soul to work more and to get to do some interesting stuff.
Okay,
to go beyond what's asked for.
Yes. Also, as you mentioned, sometimes AI can give false predictions. So, does the industry accept or adapt itself to take AI? Like, what they do to just give better prediction, or?
Like, you mean having false predictions?
Yes, like for the example of medicine of the Reno medical images. Yes.
Actually, this can be very solved when you work closely with the client, the consumer. Google Health, like in my example of diabetic retinopathy, was doing their work in the laboratory, developing an AI capable of solving the issue from a high quality input. But what we do here actually is that we work side by side with a product, what we call a product owner, which is our client, who knows more about the situation and who can help us and guide us towards our process of explaining data or even gathering data and exploring data as well. So when you work with the client directly, you get this feeling of real life. Plus, when you work in an agile manner, then this helps you. If you have a failure and the project is not going well, then you can stop it in weeks rather than stopping it after 1 year of work. That's why I emphasize on doing it in an agile manner and going out to see what happens.
Yes, sure. Thank you very much, Hajar.
Welcome, it's a pleasure.
If no one have something to add, I think we will take a 5 minutes break and we'll be back at 3:15. Thank you. Please, Hajar, can you make me host?
Of course, I'll do it right now.
I think you have to stop sharing the screen and then.
Okay. Yes. I think it's yours now. Can you check?
Okay. No, yes. Thank you.
Welcome.
I think I'm still not the host. It's okay now. So welcome back. Now we will have Professor Hashimi that will present bio-inspired algorithm, female algorithm. I make you host, Professor Hana.
Good morning, ladies. Good morning, everybody. Did you hear me?
Yes, thank you for accepting the invitation and welcome.
Thank you, Hasna. Thank you very much for your invitation. And first of all, I want to thank all the organizing committee for the effort for organizing this fantastic event and to give to young women the chance to exchange with you the survey and their scientific fields. And also I want to thank a lot Islam and Hajar for their, I enjoyed their presentations. Thank you a lot. So I will start to share my presentation. As you asked me, Hasna, that I will share my presentation to two parts. The first part, it will be just a curriculum vitae of myself. And the second part, it will be some scientific results, okay?
Okay.
So it's okay for the?
Yes, we can see the screen. Yeah.
Okay. So I am Professor Dr. Hana Hashimi from Sultan Moulay Slimane University. I am Professor of Applied Mathematics. I think, okay. But I cannot, okay, it's okay. For the moment, I occupied the administrative position in University Sultan Moulay Slimane of Bani Mellal. I am the General Secretary of the Presidents of Sultan Moulay Slimane University. So for my academic courses, so I have my Bachelor in Applied Mathematics in Faculty of Science, Ibn Tufayl University. By the way, I want to thank Professor Zubida Al-Maghazli. She was my, my professor, and she's attending this, meeting. She is online with us. I thank her a lot for being in this presentation and encourage me. Thank you very much, Dr. Zubida. So for my master's, it was also in mathematics analysis and information processing. For my doctorate, I have a doctorate in co-tutel in applied mathematics and computer science, and doctorate in mechanics from Mohammedia School of Engineering from Rabat, and National School Institute of Applied Sciences, INSA of Rouen. So since October 2015, I was assistant professor in applied mathematics in INSA at National School of Applied Sciences in University Ibn Tufayl. After that, in January 2019, I changed the university to occupy the academic or administrative position in Bani Mellal in Sultan Moulay Slimane University as General Secretary. And since the last November, we will establish a new laboratory, a system engineering laboratory, and I am the director of this laboratory. And it's a new achievement. It's in March, in this month, we had launched the International Journal on Optimization and Applications. It's a journal, multidisciplinary journal. So as I say of so academic position, it was for my academic position. As I said, I was editor-in-chief of the EGOR. I was a member of UNESCO chair in Ibn Tufayl University. I reviewed a lot of papers in several international journals and international reviews in Scopus and WOS, Web of Science. And for society, so I am the president of the Moroccan Society of Engineering, Sciences and Technologies. And also for science or for innovation, I began the first Let's Challenge. It was an international innovation competition in Kenitra, and now we will organize the 6th edition here in Beni Mellal with the Fab Lab Festival universities in Morocco. So for the research cooperation and project, so we have a lot of collaboration between several worldwide universities like METU in Turkey, ENSA in Rouen, UNINETO University in Italy, New Mexico Tech in America, United States. And the last one, it was in Almeria University. It was a MATIX project, and it's an Erasmus project. And also we have signed a lot of contracts and cooperation with SAS. It's a nice and fantastic logiciel of software of statistics and analysis. So also for some mobilities, it's normal. I am a scientist, and we participate in a lot of conference and a lot of events in science. So, and also I was invited professor to give some seminars in operational research or in graph theory in Wolfenbüttel in Germany, and for example, in France, Grenoble, and in Naivasha, Kenya. So for the scientific recognition, I am the senior member of IEEE, and I am a reviewer of a lot of indexed journal in Scopus and WOS, and it's an honor to share this with you. So I think this is just the first part of my curriculum vitae, and now I would switch to the scientific part of the female algorithm and the bio-inspired algorithms. Okay, so we can switch. Did you see my presentation?
Yes.
I will just make it on full screen. Okay, so for the scientist part, so as I said, in my field or axis of research, I work on operational research, statistics, and also modeling. So for operational research, there is a big branch. It is the optimization. So optimization, in this part, I worked on inspired algorithms. So for my outline, so just I share with you a video of motivation. And also I will talk about the optimization and the kinds of optimization. And also the next steps, it will be a brief panorama of bio-inspired algorithms. And of course, some applications in EI or in industry. So for this video, just I give you just an area of optimization and applications in the field of engineering science. As you know, optimization is a branch of applied mathematics that derives from operational research. It occupies an indispensable place for the modeling of problems in the engineering sciences sector, like electronics, mechanics, hydraulic, and also industry. So in this video, I focused on the base area of applications. And as I already said, optimization is a linear chain, and finance it is always. used in hydraulic, aeronautics, or other. This video just gives you an overview of some applications in industry, in aeronautics and electronics. And now for optimization. What is optimization? So optimization, we can say that there is several parts of optimization, but I will focus on deterministic heuristic methods. But in the methods, there are the deterministic methods and heuristic methods. And also to solve the problem, there are two kinds of problem. There are mono-objective problem and multi-objective problem. Also, there are a technique that we name hybridation. It's a technique to combine or to couple two kinds of methods in one. And also, I will give some applications, application areas.
Professor Hannah, can you hear me?
Yes.
We don't see the slides. I think now it moves, but the video we couldn't see it.
Because I make the full screen.
Now we are in the slide 4 mono. Now we can see the full screen. Now it's okay. Mono and multi-objective optimization.
Yes,
right?
and did you see all motivation and the video?
No, we didn't see it.
Oh, sorry, because you should to interrupt me in the first. So no problem. But you hear what I say.
Yes.
Okay. Okay, I don't know what is the problem because and now you see the video.
Now we can see it. Yes, now we can see it.
So I will not make the full screen. I will just share in this mode. Okay.
Okay.
Okay. So now, so I said that that optimization it's a big branch in applied mathematics. So I will talk about the mono and multi-objective problems, and also some area of applications. So and now you see the slides?
Mono and multi-objective optimization, yes.
Okay, so for the mono and multi-objective optimization, so there are two kinds of formulation. So we can, when we have an industrial problem or in finance problem, so we can extract the objective function and also extract the constraint in one function with variables. But when we want to maximize and minimize or optimize two functions, we use the second kind of formulate. It's that the variables are also function. So this is just the mathematical position. So for this video, just it is a video about just to share with you that bio-inspired algorithms are bio-inspired algorithms are algorithms from nature. So it was said that it is in a biological documentary video, but I ensure you that it's math. So optimization, as you know, it is based on method, either exact like Newton methods or branch methods, and heuristic as evolutionary algorithm. And those evolutionary algorithms are inspired from nature, from bird, from fish, from animals. So I focus on bio-inspired meta-heuristic, such as the genetic algorithm, the female algorithm, cuckoo search, Firefly or PSO. So every, as you know, every algorithm has four, I can say four fundamental characteristics like the complexity, the reliability, the robustness, and without forgetting the computing time. And this choice return to implementation of algorithm under MATLAB or C++. So the worthness, it's the absorption of several variables, less computing time, and also the reliability gives better solution even in one change of fields of applications. So I will start with some panoply of algorithms like particle swarm algorithms and also B algorithms. But for this presentation, I want to share with you the female algorithm. This algorithm that I work on now, this is an algorithm inspired from the difference between the brain of the female and the male, because as you know, I think in this presentation, we are not just ladies, there are also men with us, but we know that female has a good power in solving problem in parallel times, and they can make a lot of tasks in one time, not like men, because men, they focus in one task and from the beginning to the end. But like a woman, you can see that women can cook and also talk to phone to her mother and also think about the exam for tomorrow. So we have this capacity or this ability to exchange and to manage from a lot of tasks in one time. So this is just a beginning of one algorithm that I will share with results, but now I want just to talk about it because I didn't have the results clearly, because we just work on the implementation of this algorithm in MATLAB. And for the first results, it gives nice and wonderful results. So we'll share with you after the results when they will be in mature level. But just now I want to give just some words about this algorithm inspired from the brain of female, and I want to name this algorithm the female algorithm. So the second algorithm that I want to talk about is the particle swarm optimization. So this algorithm is inspired by the migration of birds from country to country, and also the migration of fish from oceans to oceans. So for this algorithm is inspired by the animal ethology of migration, as I say. These groups of animals scatter by following a topology, either in star or in rings or radius. And this algorithm has two variants, either with a neighborhood or without neighborhood. So for my implementation in MATLAB or for the applications, I focused on the second kind. It's the PSO with neighborhood, because it gives more reliable results, and it's explored the space larger and individuals. Each particle competes with its neighbor, and then we keep the optimal objective function evaluated. So for the second or the third inspired algorithm that I share with you this afternoon, it's the genetic algorithm. This is the famous one, based on the analogy of the DNA And even if it is very old and greedy, but it stems on compilation time. It's very greedy, but it remains a robust and reliable algorithm. Why? Because of its operator of crossing and mutation, which gives it is a young generation blast. For this algorithm for crossing, we used 80%, but for mutation, we used just 20% for this algorithm. The next algorithm is the harmonic algorithm. It's a new one that has made a revolution in the context of music algorithm, because its idea is simple, is to create harmony on the musical composition. This harmony can be expressed in a wave of periodicity of vibration in a sound interval, like we can see after that the restoration function by harmonic algorithm gives a good sound, very good and nice results. So the funny algorithm is the cuckoo search algorithm. This cuckoo, it's a bird that he can imitate the behavior of another kind of bird. So this algorithm is based on behavioral function of this parasitic bird that is not able to have a nest of its hanks, and he make the nets of other type of the bird, and the fullet does this small when they are bored of, and they try to destroy the other eggs to have the food in full. And this mechanism give us the idea to create the function of mimetic. I explained that for this bird, he is not able to have his own home or own nets to make the eggs. So he tried to explore a lot of trees, and he chose a net that he can imitate the color of the eggs of the other birds, and he put the eggs, and not this not still in this step, but the eggs also will imitate the color, the size of the other eggs in the net. And the catastrophic thing that this bird will try to destroy all eggs in the nets to be alone and to enjoy the alimentation or the nutrition alone from the parents that they are not his parents. So the famous one, also the ant colony algorithm that you know, the ant colony algorithm, it's an algorithm used on telecommunication, on GPS also to find the short path. So for these ant colonies, it seems that like the bee colonies, it's based on the visibility of the pheromone rate of the ants and the evaporation of this pheromone, and its characteristics by its strong use of the short path, as I say, in GPS and geolocalization. So I think the last bio-inspired algorithm are the firefly algorithm, or the fireflies inspired by the movement of creatures. They are insects that communicate between them by the brightness intensity that is given by the following expression. And also they communicate by them by the distance and also the attractiveness and the movement. And now I want to go to give the results of implementation of some using and hybridation results. That when I talk about hybridation, I say that this tools or this method, it's a method to combine two algorithms or two methods. There are a lot of kind of hybridation. We can have deterministic method coupled with heuristic method, or two deterministic methods combined, or two heuristic method combined. So for my research, I focus on meta-heuristic. So for these results, it's results between PSO and the genetic algorithm combining, and we can see that the genetic algorithm and PSO gives a lot of strong results by reducing the time of computing and also increase the success rate. So for the second results, it is between the harmonic algorithm and the PSO. And also when we use just a harmonic algorithm or the PSO alone, they didn't give nice results. But when we couple when we hybrid the two algorithms, we have good results. And the best hybridation result that I found until now, it's the combination between the Cuckoo search algorithm and the Firefly algorithm. And these two small algorithms are very simple in implementation, and also they give fantastic results. So for like applications of those research, I will share with you a few applications in electronics, in also mechanics, hydraulic. Okay, so for the electronic results, so it was a project between Thales and INSA de Rouen and l'École Mohammedienne and National School and the Mohammedi Engineering School. So it was in embedded systems, how we can reduce the displacement of heat in those mesh. So this work challenged the use of both MATLAB software for algorithm genetic and PSO, and also the software of ANSYS for mesh and optimizing using a transition function that communicates between the MATLAB and also the ANSYS.
Professor,
so the results as follow. We managed to minimize the three function. So this problem is a multi-objective function because we have three functions to minimize. And the diagram shows the minimized heat displacement here.
Professor Anna, sorry for interrupting. We still have 1 minute.
I have just 1 minute? Okay.
Yes.
Okay. Sorry. So I will be quick. So just I want to share with you that these algorithms are very useful on industry, on electronic, and also in mechanics. So the second applications, it was how to reduce the I don't know the word, les pertes de la construction. So we choose between two kinds of geometry of flange, from ring or sector, and for these applications we used the algorithm of PSO and Firefly. And for the last one, it's also an optimization in hydraulic, how we can optimize this function with the multi-objective with the multi-objective variables. It was a problem of Cebu River, how we can separate and how we can choose between the nice quality of water. So for these applications, the big problem it was how we can in the first identify the quality, identify the objective function, and also after that how we can make the test from a lot of parts in Cebu, because Cebu is a river in Morocco, and it's very long from Fez to Kenitra, and we have make some results, and we have just 3 stations with best water. It was station in Fez, another one in Soklarba, another one in Kenitra. So as conclusion and prospect, so for those bio-inspired algorithm, it's very useful in mechatronics and automotive industry. We can use it in traffic modeling, and also for smart city modeling, for domotics, and for smart. Okay, so I share with you some papers in several indexing journals in Scopus and UOS. And also I share with you some books talking about the optimization and meta-heuristic applications, and also one book indexed in WiDS for the intelligence system. And the last one is the International Journal on Optimization and Applications with the standard serial number. It's not yet indexed, but is in process. And also I share with you that we organized 2 famous events. The first one is the International Conference on Optimization and Applications. This year it is the 6th edition under the patronage of IEEE. And then the second one is the International Innovation Competition. It's less challenge to make to give the chance to young engineer and young people to innovate and present their project. And thank you very much.
Thank you, Professor Hannah, for this great presentation. It was full of information. I think that we cannot disagree that optimization is a very important part in any machine learning project. And I don't know if the speakers or participants have a question. Also, I want to congratulate you for the great work that you are doing in this research field. I just have one question, but I think we have to make it short for the next presentation. So you talk about a lot of bio-inspired optimization techniques, and what is the one technique that you can advise us to use in machine learning?
So for machine learning, nowadays there are 2 algorithms are very famous that I said as for the Coco Search algorithm and also the Firefly, because they are very simple to implement, and also they can absorb a lot of and a huge database of variable.
Okay. Okay, thank you very much, Professor Anna.
Thank you, Hasna. Thank you for all organizing committee for the invitation, and have a nice day.
Thank you. Can you please make me host again? Professor Anna, can you please make me host?
It's okay now?
No.
because I stopped sharing my
you should go
desktop.
to the participant and click make host in Hasna.
Where should I go?
Participant.
Oui.
Oui. Après, tu cliques sur plus et renommer host.
Ah, okay. It's okay now?
Now it's okay. Thank you very much.
Okay, thank you.
Thank you. So now we will have Professor Dina Abdelhafiz, which will present deep learning for medical imaging challenges and application. We'll make you host and so that you can share your. Just a minute. It's okay. I think you are in mute, Professor Dina.
Can you hear me now?
Yes, now you can hear you.
Good afternoon, everyone. I would like to thank the committee for having me today, and thank you, Hasna, and thank you, Islam, for the inspiring talk that you started. I loved it. So today I'm going to talk about deep learning applied to breast cancer as a part of my PhD work. Yes, so I will start with personal part, then I will go speak about my research interest, then technical part. So I graduated from the Communication and Electronics Engineering from Faculty of Engineering, Alexandria University. And then I joined the computer science program for the master and the doctoral studies. However, I didn't finish the doctoral studies because I got a scholarship in UConn in USA. And I had I was like having some struggles during the doctoral studies in Egypt because of the lack of resources and equipment needed to continue my studies. So that's motivated me to go ahead and starting from the beginning, taking courses from the beginning, and go ahead to UConn and join this prestigious university. I joined it in 2015 in the computer science department, and nowadays I'm a researcher, a young researcher at Sarta City. It's a location in Alexandria, in Burj Al Arab. So the last photo is Sarta City. And I'm the youngest researcher in my department right now. So, so as a part of my research interest in the master, it was a data acquisition for working with 3D point cloud datasets and 2D and 3D data acquisition and processing these point cloud datasets. However, these point cloud datasets came from from Tracial. There is a scanner that I used to do the acquisition by myself, go to these places and scan all this area and combine all the scans together to get this point cloud, and then process this point cloud to get meaningful output such as corners and edges, which facilitate other processing techniques. Working with this point cloud data, as a small scale was okay at that time. However, going further to something like that, doing navigation in huge scene, that was a challenge for me, and that was part of the challenges that I faced during my PhD, because the project was about finding edges and corners while you are navigating and doing data acquisition at that time. So with the lack of GPUs and the instrument needed, I had to just do the data acquisition, then offline I do the pre-processing, so I didn't manage to do it at the same time as the data acquisition. And the techniques that we used back then, it was somehow traditional, and so I thought maybe accepting the scholarship and going to UConn, I might learn how to apply different techniques to manage this huge data set. So working with big data and connecting doing communication with other professors. So I started my journey at UConn, and I joined Nabavi Lab. She's on in the middle, and she has a bioinformatics lab and a medical imaging lab. However, she was starting the medical imaging lab, and we started a project for breast cancer. At that time, I wanted to start deep learning. It was like by the end of 2016, the resources on deep learning was very little, and I started struggling again. So learning by myself, downloading each and every code on the internet to learn from it, and joining downloading all the videos from the internet and YouTube, Stanford, and attending many courses, going through many papers, journal papers, and my advisor, she advised me to make my hand dirty, which means that I download the paper and try to do the same process as the paper does, and try to re-implement it without seeing the code, and then revising the code and learn from it. So I just had hard, I had ups and downs, trying to learn by myself at UConn. But nowadays we have a huge department and deep learning department at UConn, and so I had several outstanding accomplishments during this journey. And I lost my mom during this journey, so she was calling me every half an hour to check on me, something like that. So when she passed away, I felt more motivated to finish the work done, that I traveled to do it. So I started to have a high spirit to apply all the techniques I learned to help fight breast cancer. So so that was during my PhD. Nowadays, I returned from a year and 3 months, and I started my lab at Sarta City. I have 3 students, 2 PhD students and 1 master student, and they are working in different applications, but using deep learning. I applied for the grant. It was first rejected, and but I was I felt because I'm a young researcher, they want someone like a professor, so they accept the proposal. However, the comments that I got back from these rejections, that I didn't have collaboration with hospitals here in Egypt to do my research. It was about COVID-19 detection of doing artificial intelligence detection model for monitoring the quality of treatment for COVID-19. So I started in the second call for this grant to apply again and communicating with different hospitals and the Ministry of Egypt, and I got accepted, and that was something good for a young researcher that just started her life in this field as an advisor. So with that, I find the three aspects that enable the application of artificial intelligence for medical imaging is having big data and knowing how to generate big repositories and unify the repositories. Also having GPUs and HPC center to process, to have a powerful graphical processing unit, and also implement deep learning, different deep learning architectures to specific purpose. So I found that not every architecture can be applied to any medical imaging. No, you have to find the challenges in these images, and then you try to find how you what is architecture that is suitable for this application, specific application. So starting my work, I find that the quantity and the quality of data may be insufficient. So as I told you, downloading huge repositories from the internet is not enough. What is most important is to get data set from hospitals and communicate with them. However, the quantity and the quality from the hospitals might not be good for building an artificial intelligence system. And so you have to communicate back and forth with radiologists and try to archive, find a way to archive the patient information and do the data cleaning and the identification, the pre-processing. All these process takes time, and this is just starting for the data collection. So another struggle that I had that whenever you finish your artificial intelligence model, not every hospital accepts you to do experiment with this new technology. So we ask them to test our model as a second eye for them. However, they say that we don't need it. We have radiologists. We have enough radiologists. So the struggle between the computer science and the radiologists still exists. And not all the radiologists accept that accepting artificial intelligence in the hospitals. And the other thing is that patient contest that researchers have to go through a lot of paperwork and doing the identification and anonymization process for these datasets. So that was a brief for the major problems that might face anyone in the medical field. So as a technical part, as I told you, I was interested in breast cancer detection. So as you know, breast cancer detection is second leading cancer after lung cancer, and it's increasing. The percentage of breast cancer worldwide is increasing. However, in the last few years, we found a drop in the, we realized radiology realized a drop in the percentage of this increase because of having a better screening such as mammography. So they changed it from film databases to digital databases and using the, like integrating with some CAD models. So that was somehow helping. So, so as you see here, the mammography image is like this is the front and side view for a breast, for X-ray breast. So mammography is it is a better way for radiology to see cancer in the breast. So it helps them to identify where is the location of the cancer. The problem with breast cancer is that not each woman has the same breast density. So there are a different breast density from fatty, scattered, heterogeneous, and extremely dense. The most problematic type of imaging is extreme dense and heterogeneous dense because of the tissues, overlapping of the tissues between the cancer and the tissues are very similar. So they kind of having the same color, and they have the radiology, they can't spot it very with their bare eyes. So these are the most problematic images that I wanted to deal with during my PhD, the heterogeneous dense and extremely dense, and working with artificial intelligence system to find and spot the tumors. So as you see here, the finding in mammograms, it's two types, it's mass and calcification, which is calcium in the breast. So these are the main two detections that I did during my work, and also there are a variety of shapes and types of the masses in the breast. So the mass can be very, very, very tiny, and using artificial intelligence system, they reduce image as an input for this intelligence system. So that makes the tumor very, very, very like a spot. So that's make a challenge for the artificial intelligence system to identify or segment these kind of tumors because of using small resolution images, because the resolution at like the radiology are like 4,000 or something. Like, but however, like when you are inputting, so for like UNet, for example, you can use 512 by 512, so that reduces the resolution and make the finding, spotting the cancer very challenging. So, so we moved from traditional CAD models, extracting moving from CAD models to deep learning. So we don't need to have expert. We don't need to have. We work with huge data set. We can generalize the data set, work on a new data set acquired from another area. And sorry. So my interest in this PhD finding precise segments of lesions in the breast and working with heterogeneous dense and dense images and detection of the benign or malignant tumors, because sometimes the margins between like the malignant and benign is not well defined in the dense images only. Like they are well defined if it is fatty, it's very clear. However, when you go to a dense breast, the tissues of the breast, it hides the tumor, so you can't identify if it is benign or malignant very well. And also my last interest was integrating prior years with current year's images. So the artificial intelligence look to prior years and compare it with the current year images and see how if there is increasing in the tumor size or the margins, or just that the tumor didn't increase in size, and this is an indication that this is a benign tumor. So as I told you in the beginning, I went through a lot of publication, and it meant I like in these publications I spotted like what are the famous data sets that the author use, and the kind of imaging that they use. Do they use like the whole image, process the whole image, or just the region of interest, and the resolution that they use? As you see here, the resolution, most of the resolution are very small, which doesn't give an accurate system, as they say. And so I started like memorizing and connecting all the or getting ideas from all the papers that I reviewed, and seeing the strengths and the limitations from these papers in order to go further with my research and know like exactly what I want to do. So then after that, I found that the pre-processing of like medical imaging is really important, and adding some filters to make it filters to increase the contrast of the image and the tumors, and also data augmentation is an important part, mixing data sets and getting generalized data sets from not only certain country, not from different countries, so it is generalized to new countries. And using transfer learning helped me a lot, adding generalizers. So that was some like parts of the works that helped me in like having better accuracy. So we went through a lot of data sets. These data sets, which is mixed data sets from digital and film data sets, and the one in the rectangle is we had UConn Healthcare Center with a connection with Professor Cliff Young, and he was the radiologist there. He helped me a lot in learning about medical imaging, and I used to like video call him and ask him about certain images, why this tumor looks like that, what is happening, why my artificial intelligence didn't see, why my artificial intelligence system sees this tumor as like this part as a tumor, but it is not. And we went through many discussions, and it was very helpful, very important to improve the artificial intelligence systems that I developed by time. So this is my advice. Don't count on like your knowledge as a data science. You should communicate with other people and let them test your work, and see what is go back to the data sets and to see why certain images act weird, or not act weird. I mean that why it's getting as false positive, and do data cleaning, and that was very helpful. So I used, as I told you, the pre-processing was important part in building my models, and I started with UNet in part of my work, and I modified in the UNet architecture, applied some modification to this UNet architecture. So UNet is deep learning models that takes the input image and the ground truth image, and it learns how to identify, to spot the tumor. So with a huge data set and a good architecture, the implemented approach can reach good accuracy. So as you see here, we have the fully connected network, we have the dilated network, we have the SIGNet and my proposed network with and without data augmentation, and we have the region growing faster RCNN. So these are just comparison between different architectures and the proposed model. So I tried in this model to.
Professor Dina, sorry to interrupt, but we still have 3 minutes.
Okay, sorry. Yeah, sure. So another approach that I conducted with residual deep learning systems, so that increased the accuracy in detecting small tumors, adding attention ports. So different state-of-the-art technologies in deep learning and my implementation. So I will just try to go ahead. And in this research, we consider the density of the breast while doing the segmentation or detection of the cancer. And here are some of the output. Also, these are different architectures before and after considering the density. So, for example, this is the ground truth number P. So this is the ground truth coming from the radiology, and the other columns are the output from different models. Okay, so integrating the density part with the different models increase the accuracy of these models, and that was a huge step. So I'll go forward. The last part, that integrating period years with current years. So radiology used to do double reading for in order to lower the false positive rate. So doing double reading, and it's like increasing the costs, and then reading, like having multiple views, seeing the breast from different views. Also, sorry, I don't know what happened to the slide here, so I'm sorry. So this is like an image showing you a breast. So the lower one, breast without any tumors, and the one above, after 6 years apart, this woman developed some tumors, and the work done in this part was integrating the previous year's images and the current year images to see how the woman developing cancer, if she is developing cancer or not. So here is another examples for calcification and mass that was 1 year apart. So here, for example, she had this cancer mass, and here she developed another one. So for radiology, they used like traditional techniques. So they just subtract the previous year image and from the current year image, and see like if there is a difference. Here is like that, and this is not reliable because they need to register the images first. The equipment that they used to scan the breast is different, and the timing is different, so their techniques are not accurate for this detection. So so for this part, I use a Siemens network and the input for it is previous year images and current year images. And to finalize, it's just challenges that I faced, that the tumors came from like different shapes and sizes and margins, having bad performance if you have small data sets or not generalized data sets, or it's coming from different distribution, and having you have to have different density breast coming from different breast density. And I'll just go ahead a little bit. So in this, for example, in this database, that this database came from Yukon Healthcare Center. They didn't have accurate contour, as you see here. So they didn't have accurate contour for the tumors. They just have rectangular that show where is the tumor. So the model, our model, so the column by the end, that is the detection of the tumor from the artificial intelligence system. So it shows how accurate the detection. Also, we have in the paper the metrics used to show how the intersection of reunion and dice index, but I'm not showing it here. So these are some of the work done. So as you see, this is like finding the tumors. I want to show you one of the images that, where is that? Yes, so as you see here, the black image, the one is like all of it black. The radiology, they missed the tumor. So the tumor exists and they didn't find it because of the density of the breast. However, after like 3 years apart in this image, the radiology found the tumor, and so in this specific area. So our model was succeed to find the tumor early in the period years and current years, and we contacted the radiologist who took these kind of images, and he said yes, sometimes we miss some images and it is identified as healthy images. However, the tumor exists and it's very small, and it takes time to develop and change to malignant, and then after years, like 2 years overlap, they scan again and they can spot the cancer, and they do a biopsy, and they tell her that she has cancer. So finishing up this some of parts of my publication, and thank you so much.
Thank you very much, Professor Dina. I think it is. I work in the breast cancer with deep learning field, and I know how it is interesting and how it is rich. So I thank you for this presentation. I will check. I will try to use the unit that you propose.
Yes, contact me if you need any help. So you are welcome.
Thank you very much. So now I think I will open the floor for Professor Dima, who will present her work. So can you please just give me, make me host again?
Yes, sure.
Yeah.
Just give me a minute. I try to figure out how I do that.
You have to stop the sharing the screen and go to the participants and choose me or choose Professor Dima.
Participants. And then Hasna?
Yes.
So you are...
So I think...
is it okay now?
Yeah, it's okay. So I want to welcome and to thank Professor Dima for accepting the invitation, and we are sorry for this delay.
No worries.
I'm sorry.
Don't worry. Thanks, Hasna. Thanks, everyone. It looks like it's a long schedule for the day with no breaks. So I do feel for you all having to stick with yet another presentation. But I hope that you'll find something different and interesting. Thanks again for the invite. And I understand that there are two parts to the talk today. You'll find them hopefully integrated within my presentation. A bit of background. I've just listened to the presentation before from Dina, and I guess there is a good gap in the number of years between us. I finished my bachelor in 2002 from Jamiat Bir Zaid in Palestine before moving to the UK to do a master's, PhD. I did a 3 years postdoc, and then I started as faculty in 2013. Currently, I lead a group of 7 PhD students and 5 postdocs. So the work I'm going to present today is the culmination of the work of all these individuals. But to give you a context of how things go in research and how you develop a certain line in research, it's good to see how coincidences play a part in deciding your research direction. And I guess this will be the same thing for most of you, particularly those who are aiming for a job in research or a career in research. So I joined to do my PhD in Leeds, and my supervisor sent me an email about a bicycle that was stolen on campus. And he said, we got a bicycle stolen, maybe we can do something with computer vision about it. So I started my PhD doing bicycle theft detection, putting a camera up, and then looking at people bringing their bikes and locking them, and then looking at people coming and picking their bicycles up. And this is actually one of our colleagues in the lab acting as a suspicious thief, so we can train our models. And this was well before deep learning became the popular tool to do computer vision. Moving from this, which was the popular computer vision viewpoint, having a camera up in the corner observing the world. So I then looked at how people who is actually dropping a bike, picking it up, which bicycle did they drop and pick, and more critically linking a drop that might happen at 9 a.m. in the morning to a pickup at 5 p.m. And really, when I started, this was the popular style, which is you have cameras that are in the streets, CCTV cameras, and you have footage, and that forms the base for computer vision. Over the years, the landscape for capturing footage changed dramatically. And some of you might be familiar with a few of these things. Definitely, we're all familiar with the mobile phone, or maybe the GoPro, your standard webcam, maybe the Xbox, which also has a depth camera. I don't know whether you're familiar with this, which is something very much used in films, which is a ball with 16 different cameras. And some of you might be familiar with a few of the wearable setups that I'll tell you more about. So the wearable setup is the fact that you can actually put a camera on and capture the world from your perspective as you walk around. So there are a few wearable setups already available currently, like the GoPro, which has been around for a while now, maybe a good number of 6 or 7 years. Even before that, there were lots of clippable cameras. They tend to capture not videos, but an image every minute or so, and they're used for memory logging. More increasingly and extremely popular is the GoPro, which you can wear in many different setups, head-mounted most likely, and it's used mostly in sports. And of course, we all have our mobile phone, which is currently handheld. That's how we go around the world. But you can see many people trying to find interesting approaches to make it beyond a handheld approach. I started working with wearable setups back in 2010, when everything we could set up was very experimental. So we had some sort of a chest camera. We were playing with a head-mounted camera. We had this ET style depth camera that we were mounting on top of the surface. And in this case, we were looking at some of the industrial setups, providing guidance to individuals as they perform the workflow. But why egocentric vision, which is the title of the talk and my research? This is the current world. Everybody is glued to their mobile phone as they walk around. Sometimes you just worry about people being hit by cars because of the amount of focus that they have on their mobile phones. The belief is that as soon as wearable setups become more available, we will stay connected, which apparently we all want to do, to stay connected, but we will have our hands free so that we can do the things we want to do in the world. And our focus will completely shift to looking from the screen to actually being able to observe the world, but also stay connected. And this is the future people working in egocentric vision plan for. What do we need to do? How can we be ready for analyzing the footage that comes from wearable cameras? And there are a good number of new setups that are being advertised, and these all came in the last few years, whether it's HoloLens from Microsoft, Samsung have their technique, and Facebook produced Facebook Area, which is only for research for now, but will be available for people to purchase and use. And they all have the same setup. So it's head mounted, it's a camera that is on top of your glasses, and it's observing the world from very much the same viewpoint as your eyes. And if you capture, we've been capturing loads and loads of footage from wearable cameras. This is a scope of what these cameras could capture from your daily life. It could be indoors, outdoors, sports, cleaning, arts and crafts, cooking, fixing, maintenance. This is the world as we see it. Maybe we're not yet used to watching this footage because we still have the handheld footage, but this is very much when we have wearable cameras, this is what we will be able to capture. And as I said, there isn't really a second person here. It's the same person you're observing, having a wearable camera and capturing what they're doing in their daily life. The work that we do is all focused about egocentric vision. And as I said, I will be presenting the effort of a large group. This is from the Christmas gathering that we do at the end of every year over the past 4 years, with the last year, as you know, unfortunately, being completely virtual over Zoom. Right, so what questions are we trying to answer from capturing footage from a wearable camera? And I'll start with a little bit of a short clip. So this is the view of what we know, a person smashing garlic so that they can actually use the garlic in the cooking. Standard computer vision approaches try answering questions like, what is the person doing? Cooking, and we call this coarse-grained. You can separate the person cooking from someone walking outdoors or cycling. And while this is, of course, very useful, there is tremendous success now in achieving that. So it's now mostly a solved problem. The more interesting one is to move to something we call fine-grained. For example, know that this person is in the step of adding garlic to a particular recipe or meal. Even beyond that, my group is focusing on what we call a finer-grained understanding. We would like to watch the video automatically by the computer and not only know that the person is currently smashing the garlic, but answer questions like, how was the garlic smashed? Could we have used another method? How skilled is this person in smashing garlic? When was the garlic exactly smashed? And then by the moment the video is stopped, has the garlic been fully smashed? All of these are questions that a normal person observing the video can answer, and the methods that we currently have are very far from achieving this level of perception. And of course, we're still asking questions about what information we need to use to make these decisions. Of course, there is a change in appearance. There is motion, and the question is, can we conclude force from observing the motion? Because we know there is an element of force here to be able to smash the garlic. Can we use audio to achieve the same mission? And how important is the role of audio in vision? And currently the two fields are merging. And of course, what else? Do we need depth? Do we need a wider field of view? What other techniques do we actually need to gather to achieve the level of perception accessible to humans? To be able to do that, currently in the fields of machine learning and computer vision, you need a large enough data set to achieve that. And my group led the collection of the largest data set in egocentric videos. It's called Epic Kitchens. And it's 100 hours captured from people's homes by giving people cameras. It's annotated, so there is ground truth for 90,000 actions as people kind of perform their daily tasks completely unscripted. And the dataset is publicly available. So this is, let's say, the bed set that we're using to analyze and to answer some of the questions above. And currently the dataset is open to researchers around the world to try to address basic questions, not yet the big questions are finer grained, but basic questions on recognition, detection, anticipation, retrieval, etc. The very, very basic mission people are competing on the dataset to achieve is action recognition. That is given a start and end time, assuming these are already given from a very long video. Can you really say what the person is doing by choosing from a predefined list of verbs and nouns forming the action? And over the past few years, people have been competing by submitting their models to this leaderboard so that they get ranked every year. And this year will be the third year. The winners will be announced alongside CVPR this June, virtually again. If you want to know about the dataset, feel free to look at the webpage and the set of challenges up there. I'm keen to tell you more about the research questions we've been trying to answer. So over the years, we've addressed questions like, how well is the person doing this, by proposing methods to do skill determination from video, proposing methods to analyze whether the person has successfully completed the goal they set to achieve. We've also published papers on different levels of supervision, whether to do something unsupervised or a few shot examples, and also integrating the vision and language and the vision and the audio. And in the interest of your time, I'm going to just be addressing a couple of areas just to tell you how people start, let's say, carving or answering some of these difficult questions. So these are the papers that are out there. So this is work in the past 2-3 years. And if you're interested, you can find all these works on my webpage. But to give you a flavor of how we try to answer questions, I'll tell you about 2 works presented actually last CVPR. So in this work, we are looking at action recognition. So the task I told you about, take a video and say what has been happening inside the video as a verb and as a noun. And typically the most successful approaches take as input a combination of a set of frames, this is the RGB, and also a set of optical flows just to model the motion. And these go through some 3D convolutional layers, and you basically merge the decisions or fuse the understanding in what is called late fusion. If you basically follow someone in their kitchen and learn how they open fridges and how they cook a meal, and then you try to test the model in a different environment, so you're training in one and testing in another, you realize the performance is really bad. And in fact, the performance is really bad because the feature space, so if you look at the points in the space that you've learned between the source, which is the space in which you've learned, which is in blue dots here, and the target, which is the space in which you're assessing or the domain in which you're assessing in red points, they don't overlap at all. They have nothing to do with one another. So whatever you've learned about blue is not helpful to test in red. But in this work, we wanted to do this without any additional labeling in the new environment. So we assume we have access to data from the new environment, but without the additional effort of labeling. And this is called unsupervised domain adaptation. So you want to adapt the knowledge from one domain to the other without any additional labeling. The proposed solution in this work is to utilize some level of self-supervision, a very popular topic now in computer vision, where you try to utilize the data with no labels. So this self-supervised loss function basically takes combinations of RGB and flow from the same action or from different actions. And you're doing this purely by knowing the time. This is the same time and this is a different time. And you're just learning a classifier. Purely by classifying whether things happen at the same time or not, you achieve a good clustering in the target domain. The whole space is very different, but they're still not very much aligned. On top, you need to use some of the alignment methods. And adversarial techniques are techniques where you should not be able to distinguish between the source and the domain. And what you do is that you classify the domain and use a gradient reversal layer to remove the impact of the classifier, basically, so you're not able to distinguish between kitchen 1 and kitchen 2, or domain 1 and domain 2, and you apply these on the 2 different inputs. As an output, you can then take the same action in 2 different environments. So this is a person cutting, and you can see that before we were doing all these tricks, these two, so this is the first and this is the second video, they are in completely different locations in the space. Once we introduce the self-supervision, they get closer, and along with the adversarial approach, which is the full approach proposed, they're not only overlapping, but we can correctly recognize the cutting action in a new environment without any additional labels. So again, all of these are trying to address different aspects of the fine-grained understanding. And the second method or paper I'll just mention, just to give you a different flavor, is on adverbs or learning adverbs. So adverbs are these terms in English that we use when you say you're doing something slowly or quickly, partially or fully, completely or finely or coarsely. The question is, how can we understand this level of granularity? So we distinguish between someone mixing quickly and mixing slowly. And the approach we used is very much a retrieval approach, where we take as input a video and text, and we're trying to learn a shared space for both the video and the text, where we try to make the video as close as possible, not only to the action rolling, so this is a video of someone rolling quickly some lemons, but to a modified version of that action to becoming rolling quickly. This modification is shared across both actions. So what you learn here is the same, whether you're rolling or mixing or jumping, in an approach to understand what quickly is, which can only be grounded in the context of the actual action. So there's nothing quickly alone, there is a verb that it has to be associated with. I'm gonna skip additional details on the video analysis in the interest of time and show you a few examples. Like this is a video where first we localize the action, like where does the mixing happen? And then once we know when the mixing happens in the video, we're able to predict the adverb associated. So we're able to distinguish in this case between someone mixing quickly and maybe another example of someone mixing slowly. The thickness of the border is when you localize the action. So this is the mixing action. And then from the mixing action, we're predicting the adverb. And we can do lots of interesting things like turning quickly, and we show you can generalize to unseen verbs. Right. So I know that you wanted to know the general idea. I told you about the background, how I developed interest in egocentric vision, what do I do as a group? And I thought to tell you a little bit about maybe a collection of advices. I have to admit I was quite lucky as a good student that my parents were able to support me to go and start my master's. And once I showed potential, I was able to achieve the next obvious steps, all the way to establishing my own group. But you really have, if you want to do research or postgraduate studies, I think this is a decision that you should carefully consider. It should come out of passion for continuously learning, for being a student indefinitely, because that's what research is about. It's true that you go up the hierarchy from lecturer to associate professor to professor, but the practicality is you want to continue to be a student. And that's why you want to stay in universities and stay in research. So this might not be for everyone, but if it's really for you, then definitely pursue it. But really think about it as not a title. And I know that particularly in the Arab world, we tend to really stick to titles. I want this title. I can assure you that here in the UK, no one uses titles. No one refers to me as Dr. or Professor Dima. My name here is Dima, and my value doesn't come from the title. It comes from the work I do. Really, in engineering disciplines in general, the sooner you pursue the postgraduate studies, the better. There is very limited value in doing some additional work, or of course, if you're waiting for admissions or for scholarship, that's understandable, but there is no value in doing additional work in industry between your studies and your PhD, because the field moves very quickly. And the knowledge that you take in the university will become very quickly obsolete in a few years. That's when you want to go and continue or pursue your postgraduate studies. In fact, this is life of researchers. You can wake up really excited, you get ready, you sit in front of your computer, and the first thing you face is an obstacle, something that is not working. And if this is a problem, you're really going to struggle. You need to find your pattern of how to address this immediate issue that what you're facing are always obstacles and things you need to remove rather than easy stuff. If you're the type of person who enjoys challenge and is self-motivated, self-driven, it's perfectly for you. But if it's not, that doesn't mean that people doing research are in any way better than others who are doing actual products or helping people, etc. We like just to do stuff on our own, and that's particularly a lack of interest in social skills, to be fair. But this is the truth. You really are facing obstacles all the time, but you develop, along with a supervisor, you develop a lot of interests. There's something in the chat that I don't know whether I need to follow. Oh, okay, someone's saying so true. Yeah, it's very, yeah, this is really your life. But I'm not saying it as a scaring factor. It's just that you really develop a pattern that's difficult to explain to others, where you still wake up very excited, despite the fact that you know you're gonna hit the obstacle the first time you open your screen. Right, research is a marathon, isn't something that finishes after 3 months or 6 months or 9 months or 2 years or 10 years. In fact, researchers are good at finding problems and not really ending or finishing the approach. My advice is to always seek advice from everyone who's been in this path, not from one person or a handful of people. Ask, how did you do that? What was the approach? Because this allows you to find the style that is suitable for you. Some people like to work in the morning, some people like to work in the evening, some people like to work on the weekend. You need to find your style and how you like to work, because it's a long haul. Starting very quickly and enthusiastically, you'll run out of steam. I would say the research topic is far less important than the people you work with. And I believe this was mentioned a little bit earlier. Who are your collaborators? Who is your advisor or supervisor if you're still early in the stage? Who you work with really, really matters. And that's where the energy comes from these discussions. And there is a really interesting distinction between self-belief and being self-critical. All researchers are self-critical, but they have this belief that they can do it. But they can also stand and say, this doesn't work, or this is problematic, or there are issues here. And some people confuse these by the others, developing either big egos, where they cannot be self-critical, or extreme suspicion in what they've done, where they've lost the self-belief. And this balance you can achieve either internally, or you can achieve it by finding people around you who achieve it for you. If you are more self-critical, surround yourself by good friends who increase your self-belief. If you have a bit more of self-belief, make sure that you're surrounded by people who assure you that you need to be self-critical, encourage you to be self-critical. Right. The work will speak for you. Don't worry about the fact that I am doing really good work and it's not getting attention. It might take a little bit more of time, but really let your work speak for you. Do good work and things will actually start happening. As I said, I don't think titles mean anything. And maybe at the very beginning of your career, you think they do, but they really don't. You might meet people earlier in their career that are brighter than people who have got all the big titles. Read as many research papers within and around your field as you can. Don't stop reading. And finally, a particular characteristic for all researchers is to be stubborn. Don't give up. As I said, you're going to face that obstacle every single day in the morning. And if you have that stubborn approach, that is what you need in research, to be as stubborn as possible. I hope that gave you an idea of the work I do and some of the story, as well as a few advices that I hope you will find relevant to your career paths for both female and male researchers hearing us today. If you have any questions about the dataset, some code or some publications, you can look at my webpage, and I believe there is a little bit of time for Q&A.
Thank you very much, Professor Dima, for your very interesting presentation and all the advices that you give us. We will sure follow them. It was very interesting. I don't know if the speakers or the attendees want to ask a question. We just check. I have a question. I wanted to know what are the challenges that you faced when you wanted to collect the data. Yeah, because I think that everyone, I think that there is privacy, some privacy.
Oh, yeah. So if you've seen the footage we've shown you nicely, wearable cameras only capture your hands and objects around you. They don't capture your faces, which is great. Yes. Of course, we had to really be careful. So, for example, we didn't give cameras to individuals who might have little children, who might just run into the scene. So we kind of excluded these. We told people to just check around their kitchen if there is any small personal photo that they have on the corner. So clean your environment before you start collecting, because we wanted to release the data. But to be fair, really egocentric is very much about keeping you as the person, keeping your information private. Now, as we look at the footage, it's very difficult to know who's who, but it's true. Video and privacy are two topics that tend to be mentioned jointly. And if you work in computer vision, you find that really intriguing because your face, how you look, is your public image. This is really, the face is what you face the world with. You go outside, they see you. Your face is very much your public image. However, when you click like on Facebook, this is your private point of view. No one knows that unless you actually present it. So people working computer vision always find it intriguing that people always get the word privacy with computer vision. I think there is lots of private data out there that we are sharing. I always speculate that the reason we're concerned about our footage isn't really privacy, is because we don't like to appear in less than perfect pictures. And that's a natural thing of humans, right? You look at your photo and you would say, oh, that's an ugly photo. And your friend or your sister would tell you, oh, it's perfect, because they know that's how you really look, right? But we don't see ourselves. We only see ourselves with this serene face in front of the mirror. We don't see ourselves eating or laughing or moving our hands as madly as we do. So we have this conflict between how we actually look and how we think we look. And that's why people get confused about sharing footage. I personally don't think it's a privacy concern. I think it's a preference, but that's a hypothesis, let's say.
Thank you very much. So I think we will pass to the panel discussion. So all speakers are free to ask questions if they want. I think we can start by the first question is what are or how you can deal with the pressure of society as women in data science in the field of research or in academia. So I don't know who wants to talk first.
I think this differs between different communities. Being currently located further from the Arab world physically, there is no pressure of the local society. Actually, as you know, and no one knows who their neighbors are. I would say the support group, which is the people around you, is what you generally need to be supportive. And I don't have a good answer for people who might not have a direct supportive environment, which should form that protection towards questions like, why would you want to pursue your postgraduate studies? And if the people directly, your parents, your siblings, if these are unable to understand, that really poses a very big challenge I haven't faced. And luckily, but I think that might be really hard if the people directly around you. But if the neighbors or the further people have opinions and the people around you support you, I think slowly this would just keep going. After several years of being in the UK, of course, the first year you travel abroad, you come back, people ask you, oh, when are you coming back? The second year, they ask you when you're coming back. After 5 or 6 years, they forget you. No one asks you when you're coming back. So the pressure just goes away completely. That assumes you don't have your internal pressure and you're happy with where you are. But yeah, probably my colleagues who are still in different environments might have different advices to give.
Yes, Professor Islam. Professor Islam, do you want to add something?
I just want to say thank you to all speakers, and I really loved, the very last talk. I can relate to so many things that you shared, Dima. So I'll just call you Dima.
Please.
Yeah. So I also, I just want to ask about maybe. I have like one side question later on, but in terms of challenges, to be honest, as a woman, I do not personally. I feel that the challenges that I have faced are similar to anyone who strives to be a good researcher. So far, I'm not aware of any bias that I personally have faced. Other women might have, I know of women who might have faced that, and they really struggled with that in their career development. Particularly, like if you have like a big family and you have, like kids, and like, how can you do, manage your time? How can you, if you take, for example, maternity leave, how can you still be productive because everyone expects you to publish every year? So there was like, this high expectation level from the scientific community that sometimes might be not fair, or most of the time, to women in particular. So myself, I did not have such an issue. However, I think that university all over the world, they need to support women more, which means, empowering them, giving them maybe, for example, more staff, encouraging them to progress in their careers when they take breaks, like recovering, for example, from like a short career break, how you get back to work fast is important. I personally remember I attended one talk by a female scientist. I do not really recall the name, but I remember something priceless that she shared. She said, for example, before you know that you will get really busy, whether, for example, having, your own family, kids, or you need to travel or need to go back home, or take advantage of your free time. So try to use your free time, the time you have right now, to build something, and then try to automate it, right? So, for example, try to automate, try to delegate, ask people to help you, train students to lead, and then they can alleviate the pressure on your shoulders a little bit. And it's a good thing because you're passing on your knowledge, you're helping, you're, building confidence in your students, but at the same time, somehow that also levels up the pressure, right? So I think this is important to learn how to optimize your workload in terms of, time management, in terms of, project development. Also having a long-term vision is, short, long-term. I think it's an important thing. It helps when it comes to those kind of challenges. But aside from that, I would say I've been from the lucky ones, as Dima also has mentioned.
Yeah, thanks, Islam. And sorry, I didn't attend your talk. I kind of joined a bit later. I believe, I don't want to speculate about anyone's age, but I believe I've been a little bit longer in academia than you have. And to be fair, I think things get harder as you get higher.
Wow, yeah.
I started as an assistant professor. I was very much around your point of view, which is there isn't really a systematic approach to discrimination. It's just about maybe females by default have difficult times, but there isn't a systematic approach to discrimination. As I went slightly upward the ladder, I can assure you, you're going to see a very different perspective.
Wow.
It starts getting clearer because it's fine as long as you are the junior female academic that is seeking advice from your senior male colleagues. The moment you want to say, I am no longer junior and I can here lead, or I can give my opinion in a meeting with X number of people, or I do not want to do this particular project under the leadership of X, that really shocks the concept. And I'm talking even in a Western environment. And I don't want to speculate what it could have been in a different scope. I think, and you can see there is a glass ceiling. There is a glass ceiling, and it becomes very clear when you will become the one. That's when the techniques start, the whole thing changes. And then you start talking about it, and then you start preparing. And of course, there are tens of women before me who've made things easier for me. But I can assure you, part of your role as you see some of this stuff will be, how can I ensure that the people coming are not going to face the same obstacles? And it's the culture and how things change. I'm sure that the first 10 women who went to do their bachelor's faced the glass ceiling, and now they broke it, and now everybody goes and does their bachelor. And the same. And the glass ceiling now is just okay for you to start your research group, but not much higher. Not much higher. And when they do, you will hear statements like, you got this because you were a female, because you'll start getting that a bit later in the process. And I hope that by the time you get to that stage, that glass ceiling would have disappeared. But and I know that it's breaking and it's changing and things are changing, but there is a systematic system that assumes that it's okay for you to achieve up to a certain level.
Right. Thank you so much for sharing. Actually, this is, I wasn't even aware of this, because as you said, you need to talk to so many people and ask, and I loved, when you said it that way, ask as many people as you can. So how do you carry the battle? Like when you face such a thing, what do you do? How do you react? Some people might freeze. I might, maybe, people have different reactions. So do you have any advice on how to carry yourself, how to react, how to, face such biases later on, potential ones?
It's okay to freeze and be shocked and just not expect something to happen. I think it's absolutely fine. It's okay to cry. I ended up in tears in everyone's offices all the way up to the dean. And so what? It's okay. It's okay. That's you. The thing is what you can do then to either resolve it or to avoid it happening again. And it's really, there are techniques out there for you to do stuff. My favorite one is to be prepared. Don't really go into a discussion where someone is prepared and you're not. Say, I need to think about it and I'll come back to discuss this. Go prepared, especially when in these either negotiations or when you want to resolve something. Make sure that you prepare and you think about your point of view as well as the other person's point of view. And I'll give you a good example. When we had a problem with a colleague who thought they had come up with the whole idea of the project, and I disagreed fully. I thought, this was all mine. How is this even an option? And having talked to some really good colleagues, they said, you really have to see things from the other person's perspective. They think they've been around longer. They've mentioned ideas in the meeting. They must have led this. They're not seeing your perspective. So you can learn some skills that make things easier for you, where you go and say, instead of saying, I don't like this, you say, I see that your point of view is like this, but mine are like this. And when you are prepared, you really change the landscape. You become like, oh yeah, people start seeing you differently. But I can assure you the same thing. There's something that will be very surprising that will come again, and you're going to panic and you're going to cry and you're going to seek advice. And that's fine. And that's your personality, and don't try to change it. Don't try to harden up if you expect the environment to do you so, because the last thing you want to do is to change. Make sure you evolve and you grow, but you don't change because the environment is forcing you to.
Thank you so much. Actually, I can relate to you. I remember also I watched a talk. I think it's her name is Brené Brown, like on vulnerability, the power of vulnerability. And I remember saying, femininity and being power, and power should go together. So when you're going up the ladder and when you're leading, whether you are doing a startup or whether you're starting your own research lab, that should not change who you are. You can still, a woman, powerful, feminine, and still lead in the best way. So so I just remembered that. But so definitely be true to who you are, and do not. So in the beginning, I was thinking I couldn't find myself. Should I be very, strong and direct or a bit soft, or who I am? I was completely lost, because in the beginning, you find yourself in an environment ruled primarily by our, generally colleagues, but they are men. They think differently. We know even now I do research on the brain, on gender differences, and there are differences in the brain wiring between male and females. And so in the beginning, I was just mimicking because I haven't seen lots of examples. So I just tried to be like them, the way they are. But then at the end, I found that I'm losing myself. But in the process, you learn how to adapt, and you learn how to become more authentic. And I think, I hope that after maybe, inshallah, 10 years or more, I will be more truer to who I am, authentic. And also I will learn better how to be more prepared.
Professor Ikram, Professor Islam, how did you face that situation where you find yourself lost and comparing yourself with others?
No, it's not like in terms of so it wasn't really lost. It was like, imagine yourself and sitting at a table, and 90% of your colleagues are males. Well, at ITU, at Istanbul Technical University, is completely different. So here it's more females, which is quite outstanding. So it's a different environment. But before, when I started, during my postdoc, during my also when I did, I joined different research lab, international research labs. Mostly, the majority were guys. So you just generally hang out with guys, and the way they think. And then, you see your professors, they're generally, male. So you start just, try to act or, mimic them basically. But that's subconsciously, that you don't even notice that, because when you look at the role model, you just try to become who they are without seeing, or maybe, even if it's not definite, a role model, because they are senior, and all you see is men, is you just become more, I don't know the word, it's you try to just mimic. That's what I was saying. So at the end, I was kind of losing a bit boundary. I found myself mimicking a lot. So it's like kids and babies, when they're learning, what do? They just follow or mimic, and they try to follow their parents, mimic their parents. The same thing for students and teachers. So having a diversity, this is why diversity is so powerful. All kinds of diversity, having a diverse environment, diverse teachers, diverse students, co-workers. I think it's important, because you can find better your balance and be more authentic. Yeah.
If I can just ask another question to all the speakers that are here and who does the research. I think we all know that the research field is quite stressful. So if you can give us some advice to not be stressed as a PhD student.
I would like to ask that also. How can we work without pressure, without...
I think Dima just said something very interesting, is that PhD or research is a marathon and not a sprint. I think that was interesting.
Yeah, exactly.
It's very difficult to send the stress completely out of the window. That if you think, if you're going to compare yourself to someone who goes to office 9 to 5, they close the door, they forget about work from 5 p.m. till the next day because they can. If this is the goal, I don't think this is achievable if you're doing research. But if the goal is to have a more managed or manageable lifestyle, or to be happy about what you do. So it's okay to be stressed as long as you're happy about what you're doing, right? You're excited. Stress is adrenaline. When there is a paper deadline, if you're not stressed, it's a disaster. Nothing will come out. So I think it's a stress. You don't want to be anxious, but there is a healthy level of stress, of course. And you want a supportive environment to do it. There are lots of setbacks in research. The number of times you get rejections is larger than the number of times you get acceptances. So if you don't know how to deal with it, you need to find a method to deal with it. Take a few days off, get upset about it, and then get over and get back to work. So you have to find your pattern, but it is not a relaxed lifestyle. And I don't think you mind if you like it.
Maybe I can add a word about it. What Dima wants maybe to say is that stress sometimes is necessary to achieve good work. And one advice from me is to value every bit of step that you make. I mean, you don't seek like a big goal and then you feel stressed and depressed because you didn't achieve it, but like you be happy about every step that you achieve, and that's like will lower the stress level, I guess.
Yeah, thank you so much, Professor Selma, for this advice.
Thank you. So I think we have to enjoy the journey.
Definitely. May I add something?
Of course.
So yeah, so like I really love deadlines. I think all researchers should love deadlines. I'm a deadline and deliverable driven person. However, you have stress, but as Dima mentioned, like this is a healthy stress, but you need to watch out. Like, when you have an overdose of stress, that's not good. And also, as Selma mentioned, it's so important that you value every step. So whenever you have a tiny achievement, celebrate. So for example, I'm just going to share my personal experience. I still have my me time, even I'm so busy. When I go back home, I try to spend time to do things I love. I read a lot. I can, draw, do painting, watercoloring. I can do meditation. And I can, have a cup of, enjoy time with family and friends. The weekend, I take a whole day off. I need a whole day off, at least, one Saturday. I just go out. I don't check my emails because later on, you can't really disconnect. That's a big problem. So, because you are involved in many, committees, you have lots of other, commitments. So I learned how to take one day for me, enjoy it, celebrate. And then when I go back every week on Monday, I start my Monday with a very good energy and I keep rolling. So I think having my me time is very important. Yeah.
Thank you, Islam. I don't know if Professor Anna or Hajar want to add something, or if you have some other questions to ask. So I think we can close the panel. Oh, Hajar wants to say something, I think.
Me?
Yeah.
One question for the speakers: how do you think data science is different from other other STEM sciences, let's say, in the daily life or daily work?
I don't think it's different. I think we're just in a hype in data science, and every science in STEM had its hype. I don't know, physics around the nuclear time, or chemistry around, every time that there is a hype, and during the hype there is an overload, lots of papers, lots of things coming up. We're currently in a hype, and that means there is a lot to read, a lot to follow. The field is enlarging, potential for industry is increasing, and that has changed dramatically recently. And of course, this is associated with the fact that we're providing lots of data online. The methods, the fact that we're all trying to follow the scientific method of thinking, we're doing experimentation, we're thinking about limitations. The scientific thinking is the same. I believe I don't think there is a fundamental distinction apart from the current madness. I think in the whole area of ML and AI yeah, it's a bit extreme at the time, but it will calm down. When I started computer vision, no one knew what computer vision was. Now I take an Uber ride and I say I do computer vision, and they think they know what it is. So it's now like at the peak of attention in the news everywhere. You feel you need to, yeah, to be up out and about talking about it and explaining. But yeah, this will change. I don't know how long, but it will change. It will become a normal STEM subject.
I have a question for you, Dima. So you mentioned the madness, and I'm feeling it too, also in healthcare and neuroscience. But I'm sure it's like way stronger in computer vision because I see the publications, and it's colossal. So do you think, like, I always think about those publications. So you publish, you put your heart into a paper, you feel like, this is, like, my baby, my piece of work. You've done it with your students, all of you have, or collaborators, whatever. And at the end, it might just drown, like in the literature, or, I've seen, like, lots of works, loads of works with all this madness. I don't know how do I say? So I know that the research is incremental. So you have like these tiny contributions. And then at some point you have this, explosion, for example, GANs. Now we have geometric deep learning, deep learning on graphs. And then, from that, you have, whole field spanning out, lots of papers. But at the end, at some point, there's going to be, the history will filter out something, the scientist, the history, whatever we call it. And sometimes I just ask myself, like, whatever I'm doing, I'm loving it, I am enjoying it, but what is the true value, scientific value of what I'm currently working on? So I believe in the value, but I just sometimes ask myself, how can I evaluate that?
You're answering a question that there is no answer for.
Okay.
And I'm pretty sure that if I take you now from whatever area you're working on and I drop you in another field and you find a question that you're interested in answering, you'll get the same thing. We and researchers, if the question was answered, we won't even look, right? We're gonna just jump to the next question. I think papers, and I know we call them outputs, but I don't think they are. I think papers are like small stones on the pathway you're leading. And the review process is a confirmation that you're in the right direction. That's why you put a paper out, because you want others to read it and you want them to give you feedback, either through the reviewing process or after the paper is out, to help you in this big landscape, to help you guide what you're doing next. So it's a cycle, right? You put a paper out, you get feedback, you might kind of change direction, or you might find an interesting aspect and look at other papers. So papers, it's the goal. You're after this goal, which is like this little pool in the desert that you don't know whether it exists and you're still walking towards it. Right? That's research. And the papers are these small stones that you're throwing along the path so others can follow you. And so you can get feedback whether you're in the right direction.
Yes, thank you. Awesome.
Oh, thank you very much for all the dear, the great speakers that we had today, for sharing their research, their work, and also all the advices that.
I think Hajar has something to say. Hajar, you have something to say?
We can't hear you, Hajar. I think we can't hear you. I don't know if others can hear Hajar.
No, Hajar, we can't hear you.
I think it is a technical issue. Corona time. So I was saying that I want to thank everyone for the great presentation they gave us today, and also for the advices. So I think as a PhD student, and also all researchers can follow them and make great research hopefully. So also I want to thank Professor Selma and Ikram for opening this 2 days, and also the organization committee, Bushra, Safa, Sana, and Fatem Zahra, who really worked hard to for the success of this event. I will give if you want to add something before closing the event. Bushra or Selma.
Thank you all, and hope to hear from you soon, all of you, or attend one of the workshops with you.
Yes, also I just, before closing the event, I want to mention that we still have a workshop to learn how to pitch your PhD that will be open for all PhD students, but also for postdocs who are already who have already their PhDs. So it's still open, you can register. And also the 2 days will be saved in the YouTube UM6P official YouTube channel. Bushra?
Okay, and Hasna, please, can we take a picture before we finish the session? So for all of us, if possible.
That would be nice. It was wonderful meeting you all. Maybe you can stop the screen sharing.
I think Hajar is here with us.
Screen share. Can you stop the screen share, please?
We can't hear you, Hajar.
Hajar, we can't hear you. Have you something to say? She write down. I don't know why it is not working, but I wanted to say, let us help each other as a woman. Thank you. Yes.
Thank you.
Can you stop sharing the screen, Hasna? Yeah. I think.
Right. Good luck, everyone, and hopefully you found the event as helpful as you planned for it to be, and as I understood, it was recorded, so others can also watch it if useful. And good luck.
Thank you.
Thank you so much.
Thank you.
Goodbye.
Bye. Thanks.
Goodbye. Goodbye, everyone.